We begin with the part 1, that is multiple choice question part. In this part, I will be only doing the shortcut methods because you just have to choose the correct answer. The first question is to estimate the arc length of a given function. Let us look at the problems. Here we have been told to estimate the arc length for the given function. What is the function here? F of x or y is equal to cosine x. For this given interval, what is the interval? 0 to pi by 2. I will write the interval a to b. Okay, we write the first point, that's the lower number, as a, or as the starting interval point, and ending interval as b. And they have told n is equal to 4. So imagine cosine graph, it starts something like this. You have to split whatever is the limit. It is pi by 2, that's over here, right? So till 90 degree, we will have to split it into 4 lines, 4 curves. We get these endpoints and then make the table and solve. If n is 8 line segments, that means you have to split it up into 8 line segments and then add each of them. So now, and then they are also told use your program of or a calculator. Basically, you use scientific calculator and solving it up. So we have to find 3 differences. Now, instead of all that, I will just show you a simple calculator method where you need to use this formula. I'll explain this formula. L is the arc length, what we need to solve. A and B are the limits or the intervals. See, this is the starting interval A till B, that is pi by 2. And square root 1 is a constant plus derivative of x, given function f prime of x. This f dash or f prime means you need to derive the given function, and then you need to square that particular function, and then outside this dx. So this is the thing. Now here let's first derive it. F derivative of x. What is the derivation of cosine? It is sine x. But what is the sign over here? Negative sign. This is very important. So that's it. Now all you need to do is substitute in this formula. We can directly find the answer. What is A? It's 0. B is pi by 2. And square root 1 plus, what is derivative of cosine? The given function's derivative is minus sine x, the whole squared. You need to square it up. And what is dx? Let it be as it is. Now all you do is use the calculator and we will solve it up. Here we need to use this integral symbol, right? Can you see the symbol over here? That's it. And now what do we have to put? Inside this, it's square root 1 plus, open the bracket and write whatever is the derivative. It's minus sine x, close the bracket. Now this is for x, and now close one more bracket, that's for sine. But why I'm putting the brackets? Because I have to square it up. And then what else? Dx remains as it is. And over here it is 0, and what is the above one? It's pi by 2, that is, use the fraction symbol, shift and pi divided by 2. Don't write 3.14. Don't write it in degrees because you are trig functions. Now here, if I press equal to, I'm going to get the wrong answer now. So this is not the correct answer. Why? Because it's in degree mode. Whenever you have trigonometric functions, convert everything to radian mode. That is by shift mode and option number 4. Now can you see this R mark? Whereas if you go shift mode and 3, it's in degree. This is D mark. And then if you go shift mode and 4, it'll be in radian. Now it will take some time in your calculator. It doesn't give you the answer instantly. It might take 10 seconds, or so on. Because I have a personal calculator as well. I tried it and then I will get the answer, but it will take some time. The answer is 1.9100. You approximate it will be 0.1. Now you can see there are so many methods, intervals, midpoints and everything, right? Endpoints, sorry. Now you can just do one important thing. See, this is the actual length, that is the option number C. You can do the comparison. Always the actual length, right, will be generally more than whatever you get over here. In your exam, if they ask you, say 4, n is equal to 4, your answers won't be like 1.906, 1.907. It's never going to be that. Even before this has been coming, it'll be something like 1.906. Another one will be entirely 1.873. It might be 2.123. And another option might be, negative 1.905, something like this. Now you can easily, it might be this actual length also over here. Now, but it will be easily differentiable. If this is the, close to answer, but it will be negative, this is wrong. Now, this is not the correct answer. It's never in the picture, never. Okay, this is near to the answer I got in the calculator. So absolutely, that is the correct answer. So this is how we can easily eliminate the other options and solve it up, rather than making the the endpoints, splitting it into different segments and everything. You just can avoid all this. So I'll solve the other problems. All you need to do over here is, all you need is just the derivative over here. F derivative of x is cosine x. Why? Because sine x is positive cosine x. Now just put it in the calculator. Here I will just change this part because it's the same question. It's 0 to pi by 2, but only for cosine x. Now what would be the answer? Think amongst yourself. I hope you have thought and answered. The answer will be same, isn't it? The answer should be same. Why? Because sine and cosine are same, but only the thing is, it starts over here cosine, whereas sine starts over here. The length of the arc doesn't matter. It's going in the same direction. It's just that its starting points vary. So it is the same thing. The answer is same. We are just using the arc length formula using integral. So that's it. Now we will do a lot of other problems. Now here you just have to know derivative. What is the derivative of, let me just, before I solve this up, derivative of root x is 1 by 2 root x, isn't it? So what I'll do over here is, I'll just derive it directly. It'll be 1 by 2 root of x plus 1. And inside this derivative would be just 1, so we do not need to write it. So this is the derivative. And now here, let me clear it all off. Integral, the equation is, sorry, before that, remember the formula is square root 1 plus, now the derivative square. So you have to use a brackets, 1 divided by 2 root x plus 1. And then what do we have? Close the bracket, square it up. That's it, dx. Now this limits are 0 to 3. And the answer is 3.167. You can see now it's approximated 3.168. Now look at the other answers. They are so close. It's 3.167 and 3.168. So they are so close to the actual, the actual length itself. So you can easily find which is your correct answer. And let's do this as well. Here's the formula. Why don't you try it by yourselves? Please do try it and then check for the answer. The first thing is derivation of this, derivative of f of x. See, it's 1 by x. Now the long procedure would be taking this up. It will be x minus 1 into x power minus 2, and then you take it down. But you can just remember this formula. Derivative of 1 by x is minus 1 by x squared. So you can directly take this. Now here all we need to do is same thing, integral. It is the square root of 1 plus, open the bracket, negative 1 by x squared, alpha x, square it up, and then close the bracket, square this entire thing. So now that's why this negative becomes positive. And now what are the limits? It's 1 to 2. That's it. So the answer is 1.321. And you can see the other two answers are so close to it. Here as well, let me directly solve it up in the calculator. It's integral square root 1 plus the derivative of x squared is just 2x, and that's it. But don't forget to square it. Now if you square it over there, it will be only for x squared. So use the bracket and square it up. Now it is correct. And what are the limits? The intervals minus 2 to positive 2. And the answer is 9.29. You can see here 9.2936. And this one as well, I'll quickly solve it. It is again integral square root 1 plus. Once you understand how you solve a couple of problems, the same thing, you can just skip ahead and go to the next problem. Now here the derivative of x cube is 3x squared. I'm directly writing it out, and this will become 0. 2 is 0. So close it and square it up again. Even over here you can write it as directly squaring it, 1 plus 9x to the power 4. But it's, don't take the hassle. You might do some mistakes, so just write it as it is. Minus 1, and over here it is 1. And the answer is 3.09. As you can see over here, that's the correct answer. All these problems can be easily done by shortcut methods just in your calculator. Since it is all choice questions, you can go with any method, whichever you find easy. It's up to you. Moving on to the second question, it is to find the limit graphically. Here you have been given this graph and they have asked you to find the limit at 1 minus. I'll tell you what exactly this means. 1 plus and 1 and minus 1. So what are these exactly? Now, this is the x value. Now, don't think it's minus 1. Ignore that sign for a minute. Just see what is the number here. 1, 1, and 1. So here, if you go to x of 1, where is it? This is the point, right? Left side, minus is from the left side. What is happening is, if you have minus, just, if I draw a line over here, just for understanding, just see whatever is in the left side of the line. Which is the graph, this is the point. What is the value? It is 2. So the answer over here, limit as x approaches 1 from the left side, means minus f of x. This is the graph. That is basically 2 here. And let's see what's from the right side. Limit as x approaches 1 from the right side, that's positive side. What is the answer? The value is minus 1 here. F of x, that is equal to minus 1. And then if these both are different, what is the limit of x approaching 1? F of x. If you have two different points, this jump discontinuity, there is no limit. Limit does not exist. That's the answer. Limit over here does not exist. Whereas let's do the same three conditions for minus 1 now. Okay, let's do it for minus 1. I'll write over here. Though they have asked only the final answer, let me do it for all the things over here. It's minus 1. Let me do the negative side. Then limit as x tends to minus 1 from the positive side, f of x. Now the thing is over here minus 1. So we have minus 1 here from the left side. What is the value? It's approaching towards 1. So the answer is 1 here. Even look at the right side, left and right. Both are almost 1. So what is the answer? The limit of x as it approaches 1, sorry, minus 1. We are dealing with minus 1 now. F of x. Since both these values are equal, the answer is 1. So this is how we write the limit. Look, if this minus or plus is there, go to that particular side. If it's minus, left, otherwise it's right. And carefully observe it in the graph and then write the answer. You must see along which y value. Over here it was positive 2 and negative 1, and they both do not match, so limit does not exist in the first case. These are the answers. Over here you can see from the left side, 1 from the left side is 2, from the right side is negative 1, and over here these both do not match, therefore limit does not exist. Whereas the another one both matches, and therefore the answer is 1. That is the end of question 2, a very easy question. In the question 3, we will find limits of different functions. Over here you can see these are different questions given. This is polynomial function, square root. Sorry, it's not square root, it's cube root function. This fourth one is rational function. And over here we have trigonometry. This is not trigonometry, it's inverse trigonometric functions. All different type of functions. But all of these can be easily solved in your calculators. I will show you how we can do it. Let's all take our calculators now. Here, now the first problems are very simple. Whatever value you put, you get the answer. See, because it's a polynomial, I'll just show you. You need to type it out as it is. You can't type limit in your calculator. What is there? The function that is x squared minus 3x plus 1. Now, since this is a beginning and basic problem, let's just do calc. And what is the value here? 0. Let's do 0. The answer is 1. That's it. That's the solution. What about the next one? You can directly put this cube root. Press shift and this over here. Or you can press shift and this symbol over here. and you can type in cube, that is power 3, and 2x plus 1. Now calculate this at 2, we are getting answer 1.7. Now 1.7099 is basically cube root of 5. I'll show you how. And 5 over here is 1.7099. So this is one important thing. In your options, you won't have decimal values. But in your calculator, whatever you get is decimal value. In such cases, what you need to do is write this value somewhere in a piece of paper and write at least 4 to 6 digits. 4 is enough. Then what you do is solve all the 4 options. You might have cube root 5, you might have cube root 7, and so on. But you can change these to other options. You'll get the wrong answer. It doesn't match, right? Only one correct answer matches, and that will be your solution. Now what about this one over here? Let me write cos inverses by shift and cos. That is cosine, and then alpha x squared, and then close the bracket. Now calculate it at 0. Do we get the answer? Yes, we are getting. Now this is what exactly? It's 90 degrees. But look at your answer. They don't have in degrees. It's in radian. Now if you want the answer in radian, all you need to do is shift mode and click on 4. Now look over here. The answer is half pi or pi by 2. So it's up to you. If you don't have it in radian mode, your answer will be in degrees. 90 degree is equal to pi by 2. It's the same thing. You can just click on shift and mode and 4, and then the answer will be in radian. Calculate it at 0 and you get it in radian. Now what about the last one? Let's type it out. Alpha x minus 5 divided by x squared plus 4. And where do we have to calculate that? 2. And this is the answer, negative 3 by 8. Or sometimes you might get negative 0.375, and you can just approximate, which is the correct answer. Now these are all straightforward direct problems, right? But what if we have problems like this? Now let me try solving this one. You have to write this out as it is, that is x squared minus, again, x minus 6 divided by, what do we have over here? X minus 3. Now, if I type calc and let me type in 3, what is the answer? It's a math error. We cannot solve this. Why? Because in the denominator, when you apply x of 3, it becomes 0. And whenever the denominator is 0, it's undefined. So this is a problem, right? Now what do we do in such cases? Let's click on this right or left. You'll come back to the same equation. Here you need to calculate at a number which is very close to x of 3. Now what this is, x is given as 3, but 3 doesn't work. So take two values which are very close to 3. You might think it's 2 and minus 1, right? 2 and 1. Very close. I mean, not 2 and 1, sorry. 3 and 4, 2 and 4. So 2 and 4. But can we go more closer? You can consider instead of 2 and 4, 2.9 and 3.1, isn't it? Or how about this? 2.999, which is literally 3, and over here instead of 3.1, 3.0001, which is literally very, very close to 3. So how about these values? Now let's calculate. Now we are over here, right? See, if we press 3, it's a math error. Now let's calculate at 2.999. What's the answer we are getting? It's almost 5. It's 4.999. That's 5. Let me write it down over here. For the 2.9 and left side, I'm getting 5. And what about the right side? Let me calculate it at 3.0001. It's again 5.001. So here, it's again 5. Basically, what we found out is over here, the limit as x, you do not need to write it only for one problem, I'm just telling you in detail. As x approaches 3 from the negative side, I'll just write this entire thing as f of x, okay? This was equal to 5. And over here again, we did the limit as x approached 3 from the positive side f of x for this given fifth question. This was again 5. Since these both are equal, since limit as x approaches 3 from the negative side f of x is equal to the limit x approaches 3 from the positive side, that means it's the right side, this is equal, we can tell the limit exists. And therefore, the limit of x approaching 3, 3 means for exact value 3, f of x is equal to 5. Since we know both the values are coming very close to 5, in the exactly at 3, it is 5. That's the thing. So this is how we write it out, but you don't need to write it out. You just have to check it out directly in the calculator and choose the correct answer. Now let me do this next one. Here it is x squared plus x minus 2. And what do we have over here? X squared minus 3x plus 2. Okay. Now here we just have to type calc, and what is the value here? Instead of 1, I will have to take 0.999. I'm getting negative 3. And what about the right side? It's 1.0001, and again it's negative 3 itself. So the answer over here was 5, and over here it's minus 3. Now if it doesn't match, both the sides do not match, then no, we do not have. Now this is the calculator shortcut method. Now you can use the same thing everywhere over here and solve it. You do not need to factor or anything. You can do the factoring, it's up to you. But the easy shortcut method is possible, right? Just stick to that. Then we do the trigonometric functions. Here if you directly write sine x, and okay, it's x alpha x and close the bracket, and then we have tan x, and if you calculate at 0, what's going to happen? It's going to be a math error because tan of 0 is 0 and it's undefined here. So what can we do here? Instead of 0, now this is important. See, whenever we have say 3, we take 2.999 and 3.001. What about 1? It is 0.999 and 1.001. Now what about 0? The greater than 0 is 0.001. Now don't take here as 1.99 or something like that. It is negative 0.001. This is sign neutral. It's in the middle of positive and negative numbers. So greater than 0 is 0.001, and less than it's 0.001 but minus. That's it. So we take minus 0.001, and the answer is 0.99. It's almost equal to 1. What about the right side? We have to check both, because if they are not matching, if this was something else, now it's both the cases, it's 1, the answer is 1 here. But if it was not matching, then you should tell the limit does not exist. Now what about the right one? It's tan x divided by x, and same thing calculated at, let's take, this is 0.001, and it's 1 over here calculated at minus 0. Even if you don't write 0 point, it's fine. 0.001 is the same thing. It's 1 itself. So the answer is 1. Now these are same type of problem. E is given over here by shift and ln. You get E, but I'll do the 12th one here. All you do is x squared. How do you do cosine? This is cosecant, sorry, CSC. You should know the reciprocal identities. I'll write sine x, cosine x, tan x. The reciprocal of tan, that is 1 divided by tan. Let me write it out over here. If we just divide this, now if we divide 1 by tan, this is cotangent, cot x. Very simple. 1 divided by cosine and 1 divided by sine. These are all called reciprocal identities. Now many students tend to do this mistake. I've seen students write this, 1 by sine is secant x. Wrong. It is cosecant x. 1 by sine is cosecant x. Don't think, okay, s. No. If it is sine, it is cosecant. Whereas if it's cosine, it is secant x. Now this is a very important thing, because I've seen students tend to do this mistake. Okay. So now here, square, that is absolutely fine. Now cosecant, so if you just square this up, that's the same thing, okay? Because this is cos squared, means the entire thing is squared. So all you write is multiply open the bracket, divided by 1 divided by, you can't write cosecant, there's no option for cosecant, but you can write sine x, close the bracket. Now it's x alpha and x, close the bracket, and over here also close the bracket and square it up. And now what do? Calculate it at 0.00, not points, 0.001. The answer is 1. Let me calculate it at negative 0.001. The answer is 1. So answer over here would be 1. So that's the answer. Now since over here E value is there, let me solve this up as well. I'll quickly do the answer over here. It's x and E is over here, shift and ln to the power minus 2x plus 1 divided by x squared plus x. And what do we do over here is calculate it, and you can't take 0, so you should take 0.001. Now look at this value, 2.71. Just keep it in mind. Calculate minus 0.0001. And what is this? 2.71. Both are approaching 2.71. Now if you see options, the answer is E. If you go over here, shift E to the power 1, what is it? 2.718. That is the Euler's number. In your options, you will not be given 2.718. They'll give you E value. So you must realize 2.718 corresponds to E value. And here as well, I'll do the second problem. Let's just type it out. It's 2x divided by 3 minus square root x over here plus 9. Now calculate at what? 0.001. You should put 1, and that is negative 12, and same thing, calculate at negative 0.001, and the answer is negative 12 itself. It's minus 12, that's it. And over here we get 1/4. You may not get 1/4, you will get 0.25 or 0.24449 or something like that. Very, very close to 1/4, that is 0.4. You can do one more thing. Instead of putting some values, if you do 0.001, then you might get exactly 12 as well. Sometimes you get that, but it depends, Now this is also same thing. I'll just do this one over here. It's cube of x, that is power 3, sorry, minus 64 divided by x minus 4, and calculate the limit at minus 3 point, sorry, it's not minus, 3.999, that is very close to 4. We get 48, and also calculate it at 4.0001, and you can see the value is 48 itself. If you take more approximation, see 4.000, a lot of these, we get 48. It's okay for fractions, rationals, but if it's natural logarithm, don't go to take high approximation, you might get an error. We will see such problems as well. Now this is pretty straightforward. It's just a big value. You just have to type it out. All problems work. Now what about this one here? So let us see. It's 2 divided by x. It's pretty straightforward here. Minus, there is an absolute value, right? 2 divided by absolute value, sorry, is by shift and hyperbolic functions. So that is it. And x. Now here let's calculate at negative 0.0001. What is the answer? Negative 40,000. This means it's going towards infinity. Let's see. Calculate minus 0.0. I'll just increase the zeros. You can see the number also increases. It's negative infinity basically. And let's calculate over here the positive value 0.0001. And over here you're getting 0. Are these correct? Now if you're calculating at 0.00 positive side, you're getting 0, whereas from the negative side you're getting minus infinity. It doesn't match, so the limit does not exist. When you're getting two different values, limit does not exist. Another thing, if you have remembered the rules of limits and continuity, whenever you are absolute value function, the limit doesn't exist. Similarly, you can do this by yourself. I'll just do this right side quickly. It's sine, and then use shift and hyperbolic functions. That is absolute value you get, and x. And then go away from that. 2 lines next, aside from that, or move to the right, and then close the bracket. And then over here, x. Calculate this at minus 0.001. What is the answer? It's minus 1. Let's calculate it at 0.0001 and it is 1. So these are the two answers. Oh, here does not exist, sorry. Why? Because we got minus 1 and plus 1, so it does not exist. Similarly, do the other problems by yourselves. But here now we have piecewise function 2x and x squared. Now what this means, x is less than 2. It means if you're taking any value from the left side of 2, it is given by this function 2x. So 2x, let me write it out. And since it's polynomial, everything works here. What I mean is all the value of x you can put any value of x, it doesn't get undefined because it's only the numerator. Now calculate this. I'll take it as 2 itself, okay? But understand it should be less than 2. What is the value? 4. Now don't use the same equation. Change the equation. What is it? From 2 to x squared. And put the value 2 over here. Calculate it at 2. What is the answer? It's 4 itself. X squared will be 4. So both the sides it's matching. Therefore, yes, left side and the right side it's 4 and 4. Since it's matching, we can tell the limit exists. Because 4 from the left side and the right side. If these both match, only then it is the same answer. Now what about over here? The same thing we do. Let's try this. All you need to do is type in the first equation, x squared plus 1, and calculate at this given value. It's minus 1. Remember the answer is 2. Remember that when we calculate x at minus 1, the answer we get is 2. So you should write somewhere over here 2. And let's try the next one, 3x plus 1. Calculate at what? Minus 1. You can just press equal to because it's the same value, or you can type it out again. Now look over here. Did we get the same values? No. One time we got over here positive, right? Positive 2 and negative 2. It's not the same. It does not exist. So here the limit is undefined. Basically, it's not there. So this is how we can solve it up. And what about over here? You can do the same thing, but there are 3 values. Check over. Okay, now what this means is for this and this function, you have to use the minus 1. Let's try 2x plus 1. Calculate it at minus 1. What is the answer? Negative 1. So here the answer is minus 1, but over here the limit is 3, so it does not exist at this point. Limit at x is negative 1 does not exist, okay? It does not exist. Can you see that? Why? Because they do not match. Because over here the first one we got minus 1, whereas the second one is 3. So if you had got 3 over here, then it exists. Here, if you're doing greater than 1, that means 1, yes, it will exist because we both will get 3 and 3. But look at the question. They have clearly asked x is approaching minus 1, not 1. So you have to just use minus 1 and minus 1, these two equations, and it does not exist. Same way you can try this by yourself. Now here they have asked 1. So look over here. If I calculate it at 1, what's the answer? 3. Yes, these both match, so it exists. Since here 3 and 3 we are getting both the sides, it's the same thing and it exists. The limit is there over here. Now these are again similar problems. We have done these before as well. Let's just write it out. Instead of h, type x and then close the bracket and take the power 3 minus 1 divided by h and calculated at what? Negative 0.001. And over here we're getting 3. Let's calculate it at positive 0.001 as well. Again we are getting what? 3. So both answers are there. Limit is 3. And over here please do the same thing. Just put it in the calculator and you would get the answer. And lastly we have tan. I'll just quickly do this. Tan x is by alpha x, close the bracket, and phi x calculated at 0.0001, and over here we are getting 0.2, that is 1 by phi, 1/5, and let's try it at negative 0.001. It's again 0, so it's 1/5, or 0.2 is basically 1 by phi, so that is the answer. So this is how you can easily solve this particular question. That's the end of question 3. Since it's an MCQ part, I've done only the shortcut methods and you can absolutely follow these shortcuts. The question 4 is again similar to the question 3. It is to find the limits of trigonometric functions. Here you can see we have been asked to find the limit of x times cotangent x, where the limit approaches 0. Since again it's in multiple choice part, I'm going to do it in the shortcut method. All you need to know is how to type this cotangent. X is just alpha x. And what about this cotangent? Multiply it with 1 by tan. You know tangent, right? Tan theta. Sorry, it's not shift, just tan. Okay. 1 divided by tan will be cotangent. That's the reciprocal identity. And then over here, just calculate it at 0.001 and we get 0.999 and calculate it at minus 0.0001 and here also it's 1. So answer would be 1. You have to just choose the correct answer. You can see over here, if you do it in approximations, you're coming very close to 0.99. It's very close to 1. So we just approximate it to be 1. That is the end of question 4. Another very easy topic. Please do solve all the limit problems using calculator for the multiple choice part. The question 5 is about asymptotes and we are using limits to solve them up. There are three types of asymptotes: vertical, horizontal, and then other one is oblique or slant. If you recall in grade 11, we were struggling to solve these horizontal asymptotes with rules. If the degree was 1 and this is greater than y is 0 and all that, different rules were there. Now you can ignore all the rules, we can just use limits and solve them up. First thing, vertical asymptote is the the vertical line where graph cannot be over here, whereas horizontal asymptote is horizontal line. So the graph will never touch this, but it will go very close to these points, but it will never touch. That is about the asymptotes. Now, how do we find the vertical asymptotes? It's very simple. Whatever is down in the denominator, we just make it equal to 0. Now, this numerator is x, right? So it's much easier to solve such problems. Just whatever is down, make it equal to 0. Let's solve it up. Here we go, mod 5 and 3. That is quadratic because it's power 2. Now, what do we input? Let's write this power 2 first. It's minus x power 2. What is the x term? See, this is x power 2 term, then this is x, and this is the constant term. Do we have any x term? No, that means it's 0x. And then we have plus 4, that is all equal to 0. So we just type in the coefficients. If there's nothing before the x squared term, it's 1. But we have minus, and there's nothing, so it's 1. And then we have 0, that means the x term is itself not there. Here x term is there, x squared is there, but nothing, no number. That's why it's 1. Whereas this x term is not there, it's 0, and lastly 4. So what is the answer? It's 2 and minus 2. So the horizontal asymptotes would be, sorry, this is the vertical asymptotes. I'm talking about vertical asymptotes would be x plus or minus 2. Or you can write x plus 2 and minus 2. Now, what about the horizontal one? Horizontal is the horizontal line. Okay, this one, horizontal. Here, it's very simple. We just do the same equation. See the same equation, 4 minus x squared. We take the limit of this at x is infinity and the limit of this at x of minus infinity. Same given function. Okay, it's 4 minus x squared. Now, what happens here? If we go towards positive infinity, that means we are going towards plus infinity here along the x-axis, right? So here this becomes, you just substitute infinity and you'll get, but not infinity, a big number, that's it. Whereas we go towards the minus infinity, we will come to know what's happening in the left side. So if there's a single line, then we can tell this is the horizontal asymptote. So basically, because the asymptotes n conditions, if we take x of infinity, if we take the limit, we'll understand what happens to the graph at the corners, right? So the same thing we are going to do now. Let's go to computation mode, and here we will type the given equation, that is x, that is alpha x over here, divided by 4 minus x squared. Then calculate it at what? Infinity and minus infinity. So infinity is a big number. Okay, now we can see it is minus 1.00. What does this 10 to the power minus 5 mean? This tells it is 0. This is minus, sorry, 0.0001. No, there's one more 0 and then 1. Then again 0. So it is a very small number. Let us calculate it at minus infinity. I'll just put some more nines, and you can see it's such a small number. It is 9 zeros and then you have 1. So it's almost equivalent to 0. Can you see that? It's almost 0 because it's 1. You can see it. It's 1 into 10 to the power minus 10. It's such a small minute number. So we can directly say from this, y, the horizontal asymptote y will be equal to 0. That's the answer. Horizontal asymptote is 0, vertical asymptote is plus or minus 2. Let's look over here. You can see here it's plus or minus 2 and 0. Because it's in the electronic part, directly do it in calculator. That's it. Now, denominator is same as the previous, only the numerator has changed. So let's do the limits. Here x squared. Calculate at, say, minus infinity. What is the answer? It's negative 1. Calculate at positive infinity, 999. And it's minus 1 itself. So again, we have easy same answers. The vertical asymptote is plus or minus 2, whereas the horizontal asymptote is at minus 1. We got it. Now, if you had got two numbers at left side and right side, then there are two horizontal asymptotes. You will see such problem. I think so over here it's square root. You might have two horizontal asymptotes. So first thing is whatever is in the denominator, right? Mod 5 and 3. Now when I look over here, I realize there is an imaginary number. So now in such cases, square root, don't be worried. This is equal to 0. Square both the sides, it will be 4 plus x square and you will have 0 itself. So now we can put this in the calculator. It will be x square plus 0x plus 4. So here a value is x square, that is 1, 0, 4. The values are imaginary numbers because over here it's positive. When it goes to the other side, it becomes minus. Square root of minus is not there basically, right? Looking at this only, whenever you have square plus another term and you have to equate this to 0, it's imaginary. It's not real numbers. So here there is no horizontal asymptote or vertical asymptote at all. We are doing vertical. Denominator is vertical. There is none. What about the horizontal asymptote? Let's try. Here, let's go back to the computation mode. Let's put this fraction x divided by square root 4 plus x squared. Is that okay? Now calculate it at infinity. It's at 1. Calculate it at minus infinity. Now you can see it's minus 1. There are two horizontal asymptotes. There are no vertical asymptotes. See, we don't have. There is no. X is never 0, so there is no vertical asymptotes. But for horizontal asymptote, we got y is 1 and y is minus 1. Two are there. How do we solve this? It's just the same over here. It's just plus. You will have vertical and horizontal in this case. See here, there is vertical asymptote because if you put this minus 1, 0 and 4 to the in the calculator, I'll show you over here. Just go mod 5, 3 and put in the coefficient minus 1 because minus x squared is minus 1. Then there's no x term, 0 and 4 is the last term. Here you get 2 and minus 2. So these are the vertical asymptotes. Now what about horizontal asymptotes? Let's try. Here we will just go back to the computation mode and then fractions x divided by square root 4 minus x squared. Calculate this at minus infinity, that is error. Then let's calculate it at infinity, 999. That's also an error, right? So in this case, what do we know? We know that there is no horizontal asymptote because both the sides there are errors. I hope this is clear. Now let's go to the next one. Now here you can see the numerators before were just x. It was very easy, but here we have to be careful. Why? Because we will do this mod 5, 3 denominator. It's 1, minus 2 and lastly minus 3, right? What are the x values? 3 and minus 1. These are very important numbers. 3, minus 1. Now what you need to do is you need to put these in the numerator and check. So the easier method would be just type whatever is the numerator, 3x squared plus 1. Okay, and calculate at 3. What is the value? It's 28. It's fine. It should not be it should not be 0. That's the only thing. If you put over here, yes, that's fine. Now what about calculating at minus 1? It's 4. Is any of this 0? No. So we just consider both these vertical asymptotes. And how do we do the horizontal asymptotes? We type this entirely 3x squared plus 1 divided by x squared minus 2x minus 3. Now here calculated at infinity, it's at 3, and calculated at minus infinity as well, it's at 3. So you can see here y value is 3. We got 3, right? Both the cases. So that's the thing. And what about the vertical asymptotes? It's 3 and minus 1 both exist because there is no problem with the numerator. Okay. And then what about this one now? Let's do the same thing. I will first find the horizontal asymptote because it's already there. I'll just rearrange this. It's minus 2. And here what do we have? It's x plus x. And then we have x over here, 1 minus x. So I'll just remove all the other terms. Okay, calculated at minus infinity. What is the answer? It's 0 because it's minus 10 to the power minus 7. And calculated at 999 positive infinity, it's again 0.00. It's almost 0. And 0 is neutral. Sign doesn't matter to 0. So it's very easy to find the horizontal asymptotes. But what about the vertical asymptote? Here, mod phi 3, let's put these in the coefficient. It's 1, 1, sorry, it's 1, 1, 2. So it's minus 2. All you do is see 1 and minus 2. Now here, minus 2 is fine. When you solve the about term, minus of minus 2, you'll get 3. That's absolutely fine. But let's put 1 here. 1 minus 1, what happens? It's 0. So this cannot be allowed. Your vertical asymptote, there are two vertical asymptotes, yes, 1 and minus 2. But when you put 1 up over here instead of x, it becomes 0, so it's not allowed. What do you need to consider? Only the other asymptote x is 2, and we had got the horizontal asymptote y was equal to 0, isn't it? So now here, sorry, is it 2? It's minus 2, my bad. We had got, this was the previous numbers, so we had got minus 2 and minus and 1 and minus 2. So we apply over here, we would get only minus 2 here as the answer. So horizontal asymptote over here is 0, vertical is minus 2. Let's just check the answer. It's minus 2 and 0. In this problem, we have trigonometric function and it's inverse trigonometric function, tan inverse. Doesn't matter, it's just the same, but it really helps if you understand what is trigonometry function over your tan inverse. It's something like this. It has no vertical asymptotes. It keeps on going forever. So now you can see here, there is no divided by 0. So you can understand here there is no vertical asymptotes, and from tan inverse function also, there is no vertical asymptote. But what about the horizontal asymptote? Where does it end? Just take the limit to infinity and then minus infinity. So we will directly do it in the calculator. Let's type it out over here. Tan inverse, 4 tan inverse, that's shift and tan, alpha x, close the bracket, minus 1. Here, remember you have to press shift, mod and 4 if it's not already in radian. And then what you need to do is, if it is in degree, see shift mode 3 is in degree, you will have a d over here on the top. If you convert, let me keep it in degree and I'll show you the answer. Let's calculate it at infinity, say big number 999. You're getting 358.9, it's 359 degrees, but we want exactly in radians because the answers only will be in radians. So shift mode and 4. Now you can see the value is, if for infinity, that is 999. Let me write it over here. As x tends to infinity, you're getting 5.283. And what about minus infinity? Let us do calc minus 9999. And what is the answer here? Minus 7.28. So it's here x tends to minus infinity, minus 7.283. Now, what are these values? In your options, you won't have these decimals. See, I will show what will be options. You will have something like this. You will have 2 pi minus 1, 2 pi plus 5 pi, or something like that. You need to make sure, type all the options for the horizontal asymptote, say 2 pi minus 1. This is from where? From towards positive infinity, and then press equal to, what is the value? Isn't it the same thing? Yes. And another answer was minus 2 pi minus 1. Can you see? They both match. So these are the two correct answers. All the others would be wrong answers. So that's how we come to the conclusion that these two are the answers from 2 pi minus 1 and minus 2 pi minus 1. They are the horizontal asymptotes, and there were no vertical asymptotes. From here you can tell there's no vertical asymptotes. Now let's look at this function here, ln of 1 minus cos x. Now you should know some basic things of natural logarithmic function. Here, if you know this graph, this is the ln graph. Do we have any vertical asymptotes? Yes, at 0, right? When does it occur? Always for natural logarithm, whenever the natural logarithm is 0, there is a vertical asymptote. So ln over here, when it's 0, there are vertical asymptotes. But where is the horizontal asymptote? There are none. You can try in your calculator making limits. You can see there is none. It goes to minus infinity till plus infinity. It keeps on going. Now, how do we find the vertical asymptotes? Here, whatever is there inside the brackets must be equal to 0. 1 minus cosine x is equal to 0. Let's solve it. 1 is equal to cosine x. Now here, let me write cosine x is equal to 1. In this case, you need to know what is cosine graph as well. Because whenever cosine x is 1, here, whenever cos graph is 1, that becomes 0 and it's undefined. There are all vertical asymptotes over there. So what is cosine graph? If you recall, it starts at 1, it will go like this, and then it will come up and something like that, and even in the other side, right? So all these are 1 value. This should touch over here, and they are all 1. Whereas the lowest point is minus 1 in cosine graph. So here technically this is 1, this is 1, this is 1. So there are many ones. At when does it recur? When x value is 0, when x value is 2 pi, when x value is 4 pi, multiples of pi. So you can just tell it's multiple of 2 pi, not multiples of pi. Whenever we have minus 2 pi and so on. So if you remember, cosine graph will be 1 whenever it is multiples of 2 pi, or it will be 0 again, multiples of 2 pi, right? So what we do is x is equal to multiples of 2 pi, but there is every integer multiple. So we write k here. K in the sense k is an integer. K is an integer. You should write so much. That means whenever k is 0, 1, 2, 3, just substitute 0 means 0 pi, or 1 means 2 pi, 2 means 4 pi, 6 means 12 pi, and so on. It is undefined. You will have vertical asymptotes. That's the answer. And there are no horizontal asymptotes or slant asymptotes. We can check that in the calculator. See here, if you put ln 0, you get undefined. Why? Because it's an error. This is the natural logarithm graph, okay, ln x graph, not this one. I'll show this graph in a while. Now, one more important thing is testing for what? Testing whether there is horizontal asymptote or no. Let's put the coefficient, the given question. It's 1 minus cosine x. Close the bracket for cosine, and now close the bracket for natural logarithm. And let's do calc at some values. Here you're getting, let me just change the value. See, it's just varying. There is literally no asymptote, okay? It just varies. Now if you change it to minus infinity, you can see it just varies again. So there is only vertical asymptote. What is the vertical asymptote? See over here, x is equal to 2k pi, which we wrote over here, okay? Or k into 2 pi, it's the same thing. Now this is the graph of this particular function. You can see it's having at every 2 pi, that is pi is how much? 3.1. For 2 times it's 6.28. So you can see over here at every 6.28 interval you will have a vertical asymptote. Finally, we move to the last type of problem, that is the slant asymptotes, or it's also called as oblique asymptote. They occur only when the numerator is exactly 1 degree more than the denominator. See, this must be 1 more than the denominator. Now, how do we find this? This is only done by long division. Now, whenever you have single terms, it's very easy. I'll show you how. But whatever happens in the denominator, you have to write the highest degree first, minus x squared plus 4, like this. So you need to do long division. What is up? Now, if you had, say, 2 divided by 8, how do you do it? 2 is over here. So now, generally, you will be given like this. Okay, let's take 12. 12 will be over here, 8, and then you start dividing, right? Same way here, whatever is up is written inside, and what is down here in the standard form, minus x squared plus 4. All you focus here is, since this is single term, only one step, you don't need to do anything else. Just multiply with a number such that when I multiply this with that, it should be x power 3. So all I do is x power 3 divided by minus x squared. What is the answer? This cancels off, minus x, right? So I will write here minus x. Now let me multiply minus and minus, it will be plus x to the power 2 times x. X is x cubed. That's the answer. It changes its sign at 0, right? This is the answer over here, whatever is there. So this is the slant asymptote. Slant asymptote y is minus x for this particular problem. What about the vertical asymptote? Vertical asymptote is same. Whatever is down here, see this, whatever we wrote, make it equal to 0. And we have solved this before. X will be plus or minus 2. Mod 5, 3, you will get the answer. So that's it. This is one answer and another answer. Whenever there is slant asymptote, there is no horizontal asymptote. Why? Because the numerator degree is more than the denominator. There is no horizontal asymptote, only slant asymptote. Also be careful, this difference must be exactly 1, only then there is slant asymptotes. So let's do the next one here. X squared plus 1 divided by x minus 2. What do we have to multiply here? X squared by x is just x. That's the thing. And then minus 2 times x. What is happening? Okay, here I will let you know one important thing. Whenever there are two terms, right, in the numerator, x squared, you have to write x term. Is there any x term? Not there, so it's 0x plus 1. So here I need to write 0x plus 1. Now, we multiplied x times x, you got x squared, then minus 2 times x will be minus 2x. You change the sign here, change the sign. If it is plus, it becomes minus, minus becomes plus. This cancels off. Now, solve it up. 0x plus 2x is how much? Just 2x. Now, how do you get 2x? When you multiply by what? By plus 2. So x times plus 2 is 2x. You don't need to do this. This is your answer. Here, the answer is y is equal to x plus 2. This is the oblique or slant asymptote. What about the vertical asymptote? X will be equal to 2. That's it, because we have to make the denominator equal to 0. You can see here in the first one we got minus x plus or minus 2. Here it is x plus 2, which we just now got, and x is 2. Now here there are two more problems. This one is easy because there is no x term or anything. Directly you can get the answer. But here, look here, x power 3, but there is full terms here. Let's start solving by long division. X power 3. Here you will have x power 2 plus x minus 4. Now what do you multiply it over here with? It's x. So x power 2 times x power 3 is x power 3. Then what next? Multiply this plus x squared minus 4x. That's the answer. Now it all changes, minus, minus and plus, and you cancel this off, and you're remaining with what exactly? A minus x squared minus 4x. Sorry, plus 4x. Now remember, this term exists. It's not directly the number. Why? Because if there was no middle terms, you can just tell the answer. See over here, x cube and then directly the number, right? There is no x square or x term. So when you solve it up here, directly you can tell the answer is x, because it will be x power 3 plus 0, 0, 0. Sorry, x power 4 here. And then other thing will be just 2x. Now there will be zeros in the middle. Ignore that zeros. It will be 2x, right? When you solve it, this cancels. You will have minus 2x. Look here, the degree over here is more than the denominator. This is a remainder. You leave it as it is. But here, sadly, when you solve it up, this is 0, right? 0x squared. Nothing is there. This term comes down. It will be minus x squared. So we still have to solve because this is the same degrees. That means we have to solve. How much do you have to multiply x squared to get minus x squared? It's minus 1. So x squared times minus 1 will be minus x squared. Then you don't need, because we are a number. Once you get the constant term, done. Because anymore, whenever you solve, the answer over here will be x, which will be less than this term, done. So it's just long division. I'm not doing the entire long division. See, the entire long division is done before. But here I'm just trying to do the simple, just to get the answer. Simple ways just to get the answer. And these are the horizontal slant asymptotes. Now what about the vertical asymptotes? You just put in the calculator. Let's take the calculator here. All you do is mod 5 and 3, and this is 1, 1 and minus 4. What's the answer? It is minus 1 plus root 17 by 2, and then there's one more answer, minus. So it's plus and minus. That means there are two answers. One will be this answer, another one will be, with plus. So you can see it's with plus and with minus. There are two different values, but they'll write it in terms of fractions. Now what about over here? You can just do the same thing, mod 5, but here it's power 3, so you can go with option number 4. What is the coefficient of x cubed? Let me get back the calculator. Here it's 1. What is x squared? There is no x squared term, 0. This is x term, 0. And lastly, number is 2. So it's 1, 0, 0, 2. The answer is minus 1.25. And then look at this. This is imaginary. If you have something like that plus, that will be imaginary, imaginary. So which is the only correct answer? It's minus 1.2599. Now if you solve this up, let me go back. Minus cube root, shift and this root symbol here, 2 gives you the same answer. So that's it. So this is how we basically solve. And why was x over here, isn't it? Only over here we got x minus 1. So this is how we solve slant asymptotes. And that's the end of this question. It's a bit lengthy one, but just make sure you get the answers directly using calculator. The starting ones are very easy. Only for slant asymptote, you have to do long division method. The question 6 is about sketching graphs of a function using its derivatives. And here we have two graphs. We need to sketch its derivative. In the question they have asked, graph of f is given, use this graph to sketch the derivative. Now since it's an electronic part, it's very easy. You will have 4 answers. Let me just show you from the answers how you can easily pinpoint which is correct. Now here, very important points are turning points. Can you see these turning points where it changes from increasing to decreasing or decreasing to increasing? So this is a turning point here. This is another turning point here. Those are important points because the turning points in the function f of x, here, turning points, okay? If I write turning points, then those points in derivatives, okay, f dash of x will be equal to intercept, x-intercept. Let me write x-intercepts. Now what does this mean? Intercept. Wherever there is turning point, here at 0 it's turning, right? That means in the derivative it should be at 0, it will touch the x-axis. Now here somewhere, let's assume this to be I don't know the exact value is 0.5. See, it's about 0.5. They have not given the value, but still little less than the y-axis. Here you can see this is touching the x-axis. Yeah, even over here x-axis it's touching. Why? Because those are the turning points. Turning points in f of x becomes intercepts in x dash. Now what next? How? But still that doesn't help us. There might be same turning points. It just will be something like this downwards. How will we know the exact graph? Here can you see where and all it's decreasing? The given function f of x decreasing because I started with it, and f of x increasing. F of x is increasing. So then if you write this, if you try to just remember this, it'll be much easier. I'll write f prime, that's derivative, f dash of x. What happens here? When it's decreasing below x-axis, and f prime of x here for this. See, it's 1, 2, 3, 1. This is 2, and the third one, it will be above x-axis. So let's see, wherever it's decreasing below the 0, right? Below here, it's below the x-axis, yes. Whereas this is positive above the x-axis. Same thing here. What is happening? Is it increasing? Yes, it's increasing, going up. Increasing means going up, right? Going from left to right, upside. Decreasing is going down. This was downwards, this is upwards. Positive, this will be negative. Now here this is positive, so it should be above. Yes, this is above. Now here, can you see it's going down, so it's minus. Is it in below? Yes. And then it's going up, above. So that's how easily we can tell the graph. Now, I'll not erase these which I've written, because these are important points, and we have to do the other way around. When derivative is given also, we have to solve it. So let me keep that. Here again, the given f of x graph. So I will tell you, it's much easier if you have the options with you, then you can easily eliminate the wrong answers. Now, where is it turning? Here, here, here. So there will be x-intercept over here, the x-intercept, less than that over here, x-intercept and x-intercept. Here it's down, it's minus, plus, minus, plus. So minus, is it down? Yes, it's down, minus. Then is it above? Yes, plus, above. And then over here, see, all this is above, that's fine. Where is it down? Yes, it's down again, minus, and then lastly plus. It matches. What about this? X, see, now there is no turning point here whatsoever. Is there any turning point like this? No, it's just a straight line. So how do you know which is the correct one? Now here in this case, I'll tell you one more thing. Now this one graph looks like x to the power 4. Deriving this, what happens? It will be 4x cubed, right? So this is x power 3 graph. Yes, absolutely. This is a cubic graph. Now let's go to the previous two problems. Here you can see this is parabola, it's x power 2. X power 2, when you derive, you'll get x. This is just x. This is x power 3, but when you derive it, it'll be x power 2. Now, what is this linear function is x? When you derive this, you'll just get a straight line, a constant term that is over here. Is that okay? So that is it. But now everywhere it's increasing, so it should be above the axis. So this will be the correct answer. Now, what about these two problems? Again, it's the same thing. But is there any turning point here? Look, it doesn't turn properly back, right? Over here, there is a turning point. What is this point? It is at 1, but not over here. So let's look into the answers. See, here there is nothing touching the x-axis, but here there is 1 point. But that is fine. You should see which is increasing, decreasing. If this is just a flat line, what happens is you just draw a straight line over here. Because derivative, okay, now, very important thing. Now imagine this is constant 2. What is the derivative of 2? It's 0. So you draw a line on 0. Okay. Whereas the derivative of this x, it'll be 1, right? So we draw a flat line at 1. Or it depends. If it was more straighter, you can consider it to be 2 or something like that. Approximately, not accurately. Now here, these two are easy to be done. But what about this? It's increasing right over here. This much part is above the x-axis. See, I'll just write it out over here. This one derivative is 0. Derivative, okay. And this one over here to be 1. So it's at 1. And this one is positive. So yes, it's positive. All this is decreasing, so it's minus, minus. Now what about this? It's all decreasing, right? Minus, this all decreasing, so it should be below. What about this part? It's again all decreasing. So now this is all decreasing, decreasing, decreasing. Now here, part by part, if you see exactly, this is like a cubic graph. It becomes a parabola, isn't it? Cubic parabola. Now over here, this part remains as it is. This also remains. But see this part is above. Why it goes below? Because it's decreasing. So it's minus, minus. This is also minus, but it's a parabola. So that's it. You can easily look into a few of the features and you can eliminate the other options. Okay. So that is an important thing. And this part will always be at this part itself, but it just moved down because it's minus. Now what about these lines, these two graphs? Same thing again. You can see here there's no turning point here. There's no turning point here, but it'll be two straight lines at the right. Why? Because you can see it's now this one is increasing, so it's above. Okay, it's at 1, and this is decreasing, so it's at below the axis. This was a point. When you this is a hole, this is supposed to be a point here. Okay, this is a point, and then what happens here? This this has got no turning point, so it's just below. It's decreasing, so it's below. Here this is also decreasing, it just goes below. So you can see this is fine because it's already below, but this one, it should be below as well. And there is a vertical asymptote over here. Now then, see here they have changed. What they have changed is from f prime, they have given us f prime, we have to draw the given original function. So this is known. See here, x-intercept. What is the x-intercepts? These are the three x-intercepts, right? Those will become the turning points in the final graph, and whatever is below, this one is below, right, will be decreasing, whereas the above will be increasing functions. Let's look into the graphs. Yeah, these are the graphs. Here this is, now this one looks like a cubic graph, x power 3. Original function will be one more. This is x power 4 graph. Let's look carefully. Near to the x-axis here, it's touching the intercept. One second. Not x-axis. Let's just clearly see. See, it's not x-axis. It's just little ahead of it. Okay. So what we do is, see here, just little ahead. That is the turning point. Turning point. Now, where next? Over here also, this is another turning point. Now, over here, left side, this is another turning point. Okay. And what about this part? It is, see here, it's not increasing, decreasing. We must see what below axis, above axis. This is what anything above this is above the axis, positive. So that means anything before this point, before this turning point, it's increasing. Yes, it's increasing. Now here below axis, so till then it is decreasing till this point. Then again it is above, so it's increasing, and then we have decreasing. Now this is easy because you have 4 options, right? To choose from that, it is very easy. Only one unique graph will match these all conditions. All the others will not be. Now here also, where is the turning point? Somewhere over here. You can see the turning point. It's touching the axis. No, so now again, this do not require. Now we have been given the f prime. So we are not dealing with the turning point. We are dealing with the intercepts here. See, the intercepts must be seen here. Now it's this to this. Intercepts means it will be turning point. What is this? Intercept somewhere over here, that is. Can you see? That is the turning point. Now before the turning point, it's minus, so it's reducing, decreasing. But after the turning point, it's above, plus, that means it's increasing. Now what next? It goes still over here, okay? And then there is no other intercepts. This is a flat line. Now flat line means it's a constant. Imagine this was the thing. What is the derive? If we derive x, we get 1. So this is x. See, from here to here. This part is x. Now what about this to this? It's below the axis, so it's going down here. Down, decreasing. If it's above, it's positive. Above the axis, it's increasing. So that is the difference. This is minus x. That's it. So easily, part by part, you can resolve it. Now let's do these as well. Here, looking at this, it's a parabola. It must be a cubic. But now here, this is above axis, above axis. That means it should increase, increase. And this is below axis. Look at the intercepts. The intercepts are the turning points. Can you see these are the turning points? Left of this turning point, it's positive. That means it's increasing. Yes. Minus will be decrease. Again, increase. Now, what about this? This over here, above axis, intercept. This is a turning point. See, can you see this is the turning point over here? I'll circle it out. There is only one intercept. There is no other intercepts. This is below axis, so it's decreasing. Above, it was increasing here. And over here also, it was increasing. So this is how we can get it out. Just look at some of the key features and easily deduce which is the correct graph. That's the end of the question 6. Question 7 is about continuity and differentiability. Here, we have been given piecewise equation. You can see there are 2 pieces of equation. One is for less than 0 and one is greater than or equal to 0. They're asking us to find the differentiability for both the sides, the left hand and the right side derivative. Now, basically, you're finding the derivative and checking whether it's equal or no for both the sides. So, how do we do this? Is very simple. If you're doing it manually, you have to just derive this, because I'm not going to use the formulas or anything. Why? Because this is, first of all, electronic part, and one more thing is derivatives can be easily found out by power rules, okay, rather than doing the formulas, long formulas, applying limits, which you have done earlier, and in the writing part, which is all detailed. These are anyways very simple problems. Derive 2x plus 1, it's just 2. What is the derivative over here? It's 3. And we are to apply 0, it doesn't matter because there is no variable. So here, the left side and the right side, they do not match. Are they equal? No, they do not match. They're not equal. So f derivative at 0 doesn't exist. Now, if you look at the graph, they are at two different positions altogether, you know. So here it will be something like this, and there's a discontinuity. So it's not differentiable at that particular point. That is 0. That's the answer. But if you apply the formulas also, you'll get the same answers. F derivative or at 0 doesn't exist. Now I'll show you in the calculator. Here, since the x value is given, you can easily derive by pressing the shift and this integral symbol. You get derivatives. Type in the equation 2x plus 1. What is the x value? We have to derive it at 0, because we need to find at 0, isn't it? It's 2, and over here you just change this to 3x and it'll be 3. Similarly, you can try the other problems. It's all at 0, so I'll just change this to 0. The answer is 0 itself. Obviously, it's a constant. And then 2x will be, that is alpha and x. At 0 will be 2. So again, it doesn't exist. Why? They do not match. 0 is not equal to 2. This is wrong here. The limits do not agree. Why? Because it's 0 and 2 doesn't equal, so it does not exist. Whereas if it was the same numbers, then it exists. So let's see over here. I know for sure, because you will have x and x over here. The answer is 0 and 0 here. See, it will be x power 2, that is 2x after you derive. When you apply 0, it's going to be 0. And over here, x power 3 also is going to be the same thing. So it's again 0. So anything with x power 2, 3, when you derive, there will be a x term. And then this apply this 0, it's 0 itself. So yes, limits exist. Since the one-sided limits are the same, you know, left and right side are same. Even over you can do it by yourselves. Now I'll do the second one first. X squared plus 2x. That at 0 is 2. What about the above one? Yes, it's going to be the same thing, right? 2x is 2. So both the answers are correct. Both answers are not correct. It's same. That's the main thing. Since both the one-sided limits are same, we can tell it exists. And that's the end of question 7, which is a very simple and easy question. Before we move on to the next question, a humble request to all of you. If you're finding these videos helpful, please do share it with your friends. Let them know about this channel. There are more than 1,000 videos related to math. Another humble request to all of you, please do subscribe to my channel. I want to thank all those who have subscribed to it. As you can see, only 22.3% of my viewers are subscribed to the channel. It would mean a lot to me if you could just hit the subscribe button. Question 8 is to find the velocity and acceleration for the given position. Here you can see we have been given the position s of t, and we have to find the velocity and acceleration. So I will do the manual method using the power rules, because this is a very important method. No matter what, you have to learn this. And the calculator method would be much more complicated than directly solving it out. So what do we do is, you just remember, when we derive derivation prime of s dash, see, if I derive, it's going to be s prime of t, right? This is the velocity. Derivation of position is velocity. Let's derive it. This 2 comes down, will be minus 32t to the power 1 plus t to the power 1 is 0. So it'll be, it's 1. T to the power 1 is 1. So we get 40. And over here, it's t to the power 0. There's nothing. So it's basically 0, constant, 0. Now, that is the velocity. That's it. What about the acceleration? They have not mentioned at any specific time interval, so you just leave it like this. Okay, you can omit the last part, that is 0, so nothing over there. What about this acceleration? Acceleration is double derivative of s. Sorry, this will be s, that's the position, double derivative or it is the single derivative of the velocity. So basically, we'll derive this velocity, you'll get acceleration. Minus 32 derivative will be minus 32 only, and this will be 0. So that's the answer. That's it. You have to derive the given position twice. For velocity, it's once. This is velocity. It'll be minus 9.8 times t plus 12. And derive it again, it'll be acceleration. It'll be just minus 9.8. So always remember, this is single derivative of the position. This is double derivative of the position. Or you can write it as single derivative of the velocity. That's it. What about this? It's a square root. If you remember the formula for square root x, it's 1 by 2 root x. But if you're thinking, how does that happen? I'll just do it over here. So this is basically t to the power half. Square root is radical means half. Plus 2t square, right? Now half comes down, the power rule. Just apply the same thing. Half comes down, it will be t. Half minus 1 will be negative half, isn't it? Plus this 2 comes down, it will be 4t. But here, let's just rearrange this a little bit, because I know whenever the numerator power is taken down, the power sign changes. So from minus, I can make it positive by just taking it down, plus 4t. Now here what I can do is, instead of writing it t to the power half, I can write it as square root, because that's the original form, right? Plus 4t, that's it. And now if you derive this again, what are you going to get? You're going to get acceleration. So this is the velocity. So now this is the answer, yes. But I'll just use this to derive, because it's much easier when it's in the power to derive. So this is the velocity, right? For acceleration, I'll just derive this one. Okay. So half is already there and power half. So what happens is, I'll do it in steps. Half multiplied by minus half, because this power comes down, and subtract this by 1. Negative 0.5 minus 1 is negative 1.5 or negative 3 by 2. Because you're subtracting and negative numbers, they just add up. Plus 4 times t is gone, it's just 1. So now this is the answer. Now what did I write over here? I have missed the t altogether. It should be written over here, t to the power minus 3 by 2. Now when you multiply this, it's negative 1/4 t to the power. I'll just take that t to the power down to the numerator. So it's t to the power positive 3 by 2 plus 4. And generally, it will be written as 1 by 4. See, whatever is the power, right, will remain. Whatever is 2, that means it's a radical, right? See over here, radical x means x to the power 1 by 2. If we have, say, like this, 4 here, and then over here you have 3. So that would mean x power 3, whatever is over here, you have to write it down. This is 4, 3, 4. That's what it means. So here as well, I'm just writing this radical as over here. If it's only 2, we don't write it. Okay, that's the thing. If it was 3 or 4, we write it over here, whatever the number. And t to the power 3. That will be plus 4. So this would be the final answer for the third question. You can see here. Okay, they didn't go in so much depth, but this is also correct, because generally in MCQs, right, they don't give it as it is. Like this simple answer wouldn't be there. They will do it in a complicated way. They're going to take it down and write the radicals and everything. So that's why I solved it. But anyways, over here, they have just given it in very simple form. And lastly, we have over here, in terms of 1 by x, if you remember the formula, it's negative 1 by x squared. How does that happen? Because when you bring the t up, it'll be t to the power minus 1. And then we can solve it up. 10 minus 10 multiplied by minus 1, t to the power minus 2. Now we can just solve it. 10 minus 1 and minus 10 will be plus 10 t to the power negative 2. This is the velocity. Now to find the acceleration, you have to derive this again. It's going to be 10 plus 10 times minus 2 t to the power minus 3. The final answer would be, this is, till over here we have velocity. Now it's all acceleration. So the acceleration would be 10 minus, sorry, this is going to go off. My apologies. What is the derivation of 10? Don't do that in the exam, what I just now did. Very, very wrong. I would have, completely got it wrong. So 10 becomes 0. That's dissolved. When you derive a constant, it's 0. So that is not there. It's just this term that's there. So here, this is the question itself. Now from here, okay, this is S of t. I've just taken it up. From here, you can see that's how we rearrange it. And now minus 20 t to the power minus 3 is the answer for acceleration. You can see that's how we write it. And that's how we can easily solve it. Now, even you can check your answers in your calculator. How do you do that is, let's take our calculators first. Let me take this first 21st question, and then we'll solve the others. If you want a single derivative, what we do is shift and dy by dx, isn't it? Now here, negative 16 alpha x squared plus 40x. We can't put t, so we put x here, and then plus 10. Just take any x value. I always go with 1.5 or 2 or 2.5. Don't take 0 or don't take 1. That's the only conditions. And just press equal to. It's negative 8, right? Now the first derivative is the velocity. If at all you put an x value here of 1.5, you must get minus 8. Let's try that. Minus 32 instead of, you can directly write 1.5, or you can write it as x plus 40. Don't do the derivative of this. Just calculate x value of 1.5. 1.5. It is minus 8. So only the one which matches gives you the answer. But this particular method is only limited for single derivative. So there is no way you would get the double derivative of acceleration. You will just get the single derivative over here. So this is the thing. And to get the double derivative, you have to know the power rule. So power rule is a must. I'll just show you how we can do it over here as well. See, let's do derivative first of the question. That'll be 10 minus 10 divided by t. And take a value, say x, I'll just take it as 1.5. The value is 4.444 and it goes on. Now here, what is the velocity? We got 10 t squared, but it's minus. So there'll be 4 options. You have to try it for all. Calculate all of them at the same x value which you considered for the derivative, that is 1.5. And you can see here it's 4.444 and it goes on. Whereas all the other options will give you different. Imagine they had another value, say 1 times. And if you calculate it at 1.5, here it's not the same. 0.444, which is completely wrong. And say another question was like this. Calculate at 1.5, the option I mean, it's different. So only one option gives you the correct answer. But it is completely limited only to one single derivative, not the double derivative. So knowing power rules is a must here. And that's the end of the question 8. Very short one. But please remember, the power rules are used for derivative. Calculator can only be limited for a single derivative problem. The question 9 is applying the chain rule for differentiation. Here we have been told to find the derivative for this given function here. H of x equals function of g of x. And we need to find the h prime or the derivative of h for 1. Now this cannot be solved in calculator. We have to solve it using the differentiation rules. That's mainly the chain rule. Now there are lots of values given. That is fine. You can ignore that for now. Let's first solve the derivative, the h prime of x, because we have h of x, right? So the derivative over here, h prime of x would be equal to, now this is the outer function f. The outermost function is this f. So first derive it, f prime of g of x. Then what do we need to do? Derive whatever is inside, that is g prime of x. So this is the condition over here, what we got. Now then, what do we know here? We know f prime of x, right? But we need to solve for 1. So instead of x, we have to put everywhere 1. H prime of 1. And over here equals to f prime of g of 1. Instead of x, everywhere you need to put 1. That's it. Then g prime of 1. Now let us substitute. We need to find this. We do not know. That is what we are finding in this question. H prime of 1. But here we know that g prime of 1. Do we know that value? Yeah, we know g prime of 1 is minus 2, right? So this is minus 2. Okay, very easy. What is g prime of 1? G of 1, sorry, it's not prime, g of 1. We know it is 2. Okay, so that's going to be f prime of 2. But still it's not over. We know g of 1. That's only the original function g of 1 is 2. We substituted instead of g of 1 as 2, and then g prime of 1 is minus 2. But now there is still one more thing. F prime of 2 is formed. What is f prime of 2? That's 3. So here now, h prime of 1 will be equal to this f prime of 2. We know the answer is 3 times minus 2. So the answer will be negative 6. 3 times 2 is negative 6. So it's first just derive it up, then input whatever is known. This is how we basically solve it. I hope this is clear. Let's do the next one as well. We can use the same one over here because the derivation doesn't change, the same condition, right? So what I will do is only these parts I can change and write it now. That is h prime of x. When you derive it, it will be equal to f prime of g of x multiplied by g prime of x. That means whatever is inside, you derive it. I'll just give an example in terms of functions. If you had sine 2x here. Now what happens? You derive sine first, it will be minus cosine 2x, and then you derive whatever is inside. 2x derivative is 2, right? So this is the same thing what is happening over here now. I hope that is clear. Now here then, let's look what we need to find is 2. Instead of h prime of 1, we have to put h prime of 2. So this becomes 2 as well, and this is 2. Let's see what are the values known to us. First, we need g of 2. Do we have? Yes, g of 2 is known. F prime of 3 is what we need. We need. See, g of 2 is 3, isn't it? So instead of g of 2, we write 3 multiplied with g prime of 2. Do we have? Yes, that is 4. What is f prime of 3? That's over here. So we need to substitute this entire thing. You know, f prime of 3 is minus 3 times 4. So we'll have negative 12. That is h prime of 2. That's it. So this is how we basically solve it. We got minus 6 in the first case and now minus 12 in the second case. Now here we have some interesting problems. A function f is an even function if f of minus x is equal to f of x for all x, and it is odd function if this negative sign remains, will come out of the function for all x. We need to prove the derivative of an even function is odd and the derivative of odd function is even. Okay, let's just make sense of this. First of all, they have told what is even function. Even function would be this one given. F of minus x will be equal to f of x. The minus sign is dissolved. Whereas odd function also is given. Odd function is here f of negative x, that will be equal to minus f of x. Now then, if you know so much, can we just find the derivative directly, because they are asking us to prove the derivative of an even function. Let me write over here what would be the condition. If we derive this even function, derivative of now when we derive this, what do we must get? We must get odd. That means, see, odd function just has a minus sign outside. Right here we must have minus basically. So this is the thing. This is what they are saying. If we derive the even function, this is the even function. If we derive it over here, if we derive this minus x, we must get minus f of x. Whereas if we derive the odd function, when we derive this, we must get even function. That means the minus sign is dissolved. Okay, so this is the condition. Now here one thing is missing. Sorry, I missed one thing. Derive both the sides. This derive. Now derivation of even function must be odd and derivation of odd function must be even. This is the condition they have specified to us. Now let us see whether this really is true. Let me go back to the color. Here just derive on both the sides. What's going to happen? F derivative of minus x. Now here minus x also needs to be derived. It will be minus 1. That is derivative of f of x, right? Derivative of this. Now then, this minus, right? Let's take it to the other side. Or just multiply through both the sides by minus 1. You will get f prime of minus x. This minus 1 goes off. But here there will be minus f prime of x. Absolutely, right? When we derive the even function, we get an odd function. This is odd. See, even function means f of minus x must be equal to f of x. Whereas odd function f of minus x would be equal to minus f of x. Now when we derive this function here, we are getting minus f derivative of x. That means, yes, this is odd because minus is there outside. Let's derive this one now. When we derive over here, f prime of minus x multiplied by minus 1 will be equal to minus f prime of x. Now multiply all the sides. Say minus 1 is there. Multiply throughout by minus 1. It's going to be f prime of minus x. That will be equal to f prime of x. Now this is right side even, right? So this is hence proved. Yes, that is true. And we can tell this is a true statement. By the way, this is a electronic part. You will have to choose from options. So proving problems do not come. Problems like this will not come, but this is the understanding. Odd function, when you derive it, you will get a even function. When you derive, you'll get odd function. The derivative of odd functions would be even. Now then, see over here, the same thing is told. So that's the thing. You can just follow this one, which is much easier to understand. And even this problem, again, I don't think this will come, but anyways, let's go through this. If the graph of a differentiable function f is symmetric about the line x is equal to a, okay, it's symmetry. So what comes to my mind is a parabola, because it's very easy to remember a parabola, right? Now imagine this x is equal to a, this is the line, okay? This is the line. What can you say about the symmetry of graph of f derivative? Now here, what does symmetry mean? F of x will be equal to f of x. Sorry, now this is given as a. Let me take it as a. Now imagine if I go to 1. What is the y value? It will be the same y value at minus 1, isn't it? Or if I choose this point, whatever is there, it will be symmetrical to the opposite side as well. So if I go any value here, say minus x, it will be equal to the plus x value. Now this a line, if I add over here, or if I subtract here, this must be equal. Then only it is symmetry, because this function f is symmetrical, isn't it? Now the first one is a, or you can write it as x and a, but since they mentioned x is a, I've taken it like that. Here it is a plus x and a minus x. I hope this much is completely clear. Now then, we need to find the derivative, right? Let's just derive this function and see what happens. I will derive this over here. A plus x. What is the derivative of x? It's 1, so I'm not going to write. Multiplying by 1, it's the same thing. Now here as well, derivative of a minus x. And then what happens? Derivative of minus x will be minus 1. So this is the thing. Let me derive it. Now let me simplify it, sorry. The derivative of the symmetrical function will be equal to minus of derivative of a minus x. Now basically what happened is the same derivative, both the sides are derivative, but this is an odd function. The derivative would be odd function. So basically what happens is, if you say a point f of x, this side I have taken a point of phi, y is phi, right? This will also be phi, but on the other scale. Okay, it will be down phi, that will be down. So this will be minus phi. Why? Because if this is phi, if derivative function is phi, your minus is this, so it will be minus phi. So that is the thing. Now basically that's it. So that is what we have over here. So you can see the derivative would be minus f of a. This is called point symmetry, I guess. But just if you do this, that's enough. But this is again not, we do not use proving problems for electronic part. But if you understand the concept, that's more than enough over here. Now these problems are important. Let's solve these all. Here f of x squared is given, f of x the whole square is given, and function multiplied by f of x is given. There are two functions here. Now they are not given in terms of x or cosine or sine, so we cannot use calculator over here. We need to derive it manually. Calculator may work for some problems, but if you have similar options, it cannot be used. So please don't use calculator. Let's solve this up. F derivative, first thing, what is the outer function? It's the f, right? F prime of x squared. Now what is the inner function derivative? It will be 2x. That's the answer. Now here outer function is 2, so it will be 2 f of x. Then what is the inner function? Derivative of f of x. That's it. Now what about this? It is two functions, right? Oh sorry, this one is outside and then multiplied to this function. In the sense, when we derive this, it's going to be f prime of f of x. Okay, that's outside derived. Then whatever is inside, derive f of x. and then derivation of x is 1 basically. So it's chain rule over here. I hope that's clear. See here it's 2x. They have rearranged and written it's 2x f prime of x squared. Here it's 2 times f of x, f prime of x, and lastly we have f prime of f of x times f prime of x. I hope this much is clear. See here f prime outside, then whatever is inside. Then again we have to derive inside thing. That's it. Now, if at all this x was something else, x power 2, then over here it will be x power 2, then we derive again x power 2, and then we have to write 2x. What I mean is, if at all it was a complicated problem like this, then first we derive outside function, it will be f of x squared, done. F prime, this is done. Now what is inside? This f of x squared. So it will be f prime of x squared, done. But then we have to multiply whatever is the derivative over here, it will be 2x. So there will be 3 parts. So that's how we solve it, but that's just my own question I gave you. This is all over here, done over here. Now over here as well is the same thing. What is the rule for square root? I hope you remember square root x derivative would be 1 by 2 root x. So directly I can write, so first one, outer function f prime of square root x multiplied by 1 by 2 square root x. What about this one? It will be 1 by square root f of x multiplied by 2 is there. 1 by 2 square root x, right? Here instead of x we have this entire term, see square root x, right? But over here we have f of x, so instead of x I just put f of x. But then I have to derive whatever is the function f of x. Now what about over here? See, this is important because now this is the outer function, yes. I will write f derivative of x, f of x, that's done. But now when I derive the inside function, there are two terms, x and f of x. I have to use the product rule. If it was a times b derivative, it will be a prime b plus a b prime. This is the rule which I'm going to use. Here, derivative of x will be 1 times f of x as it is the second term, plus a term is as it is, and then I write f prime of x. This is the thing. And then what we write is f prime of x, f of x. Over here, f of x plus x f prime of x. I think so we can leave it like this because they have not asked you to simplify to the lowest. This is enough. No need of multiplying again inside. I guess this is the correct answer. Yes. Over here as well, yes, this is the correct answer. And over here, we're getting f prime of x, f of x. And yes, this is it. Usually we don't go to multiply this. It's already simplified, so leave it like that. And here as well, f of 1 by x. What is the derivative of 1 by x? D by dx of 1 by x will be equal to minus 1 by x squared. This is the answer. This is the derivative rule. Now here first f prime of 1 by x multiplied by minus 1 by x squared. That's the answer. Here we have 1 by f of x. So it's minus 1 by f of x squared times f prime of x. Because first I do 1 by x. Instead of x I have f of x. That's fine. Minus 1 by x squared. Then whatever is this x term, I have to derive it. So derivation of the x term would be x itself. F prime of x itself. And now over here we have quotient rule, a divided by b, that is given as a prime b minus ab prime, divide, this is prime over here, divided by b power 2, the second below term, okay, is b. Now first one would be f prime of x by f of x. Simple. But now here it gets complicated because we need to square the below term. I'll write it like this, f of x all squared, and above derivative of x will be 1, and multiply this only f of x minus the x term as it is, and derivative of f of x is f prime of x. So that would be the answer. You should just imagine this as simple terms. Okay, you can consider this as a, solve it up and then substitute back as well, but this is much easier to understand. You can directly solve it because it's not so complicated. So here you can see it is minus 1 by x, minus is outside, 1 by x squared, and f prime of 1 by x. Over here it was minus 1 by f of x the whole square and f prime of x. And lastly, here it was f prime of x by f of x, and here we have f of x minus x f prime of x divided by f of x the whole square. As it is, these are the correct answers. I hope this is clear. You can directly write it without any extra steps. And the last one over here, we have two terms. The derivative of 0 is 1 is 0 plus f prime of x squared multiplied by whatever is inside, that will be 2x. That's it. You can rearrange and write. Generally they write it like this in the answers. So choose what, once you do this, choose the correct answer. You should look into the options and choose the correct answer. What about this one? The square is outside, so it will be 2 times 1 plus f of x. Now I derive whatever is inside. 1 is 0, but this one over here will become f prime of x. That's it. Now here it is f prime of 1 plus f of x. Then again, derivation of inside, this will be 0, and we have f prime of x. So that's the answers. Chain rule is pretty simple. It's like peeling a onion. From outside you need to solve one and then go inside and then inside. That's it. So here we solve this power 2 first, then whatever is inside we try to find the derivative. So these are the answers you can see as it is. Now here what they have done is they have simplified it. No, not simplified, sorry, they have just rearranged. They have written 2 and f prime together, and this is as it is, you can see. And lastly over here as well, they have left it as it is. They have written this term first and then as it is. So that is basically the end of question 9. You need to try solving it by writing, because there is no shortcut methods, there's no calculators method for this. Please make sure you solve few problems on chain rule. Once you understand how chain rule is applied, then they will be much easier. The question 10 is derivative of an inverse function. I'll be very honest with you guys. When I was in my first year engineering, I believe we had this topic, and I used to struggle a lot. It never made sense to me. I will explain you in detail how to solve this, but first I will teach you the shortcut calculator method as well to solve any of the inverse functions. But before that, I'll just write down the formula. Whenever you have to find the inverse, they have told f as an inverse g of x, that is given to us. Now there is a formula for this. The derivative of g of x, this is what we need to find, right? The derivative of the inverse, so that is given as 1 divided by the derivative of f at g of x. So it's a little bit complicated. We have been told f derivative is inverse is g. We need to know about the derivatives as well, isn't it? But f derivative is very simple. We can find it over here. But what about g derivative? That is what we need to solve from this given thing. Anyways, we'll do it step by step. Now let's take our calculators. This is the shortcut method. All you need to do is type the given function over here, x to the power 3 plus 4x minus 1. Then equals to whatever is given over here as a value, you just put it as minus 1, shift and solve, and what is the answer here? You're getting 0, so x value is 0. We got x is equal to 0 for this particular function. Now this, whatever you get, is basically g of x. I will tell you in a minute why and everything. So g derivative of x is equal to 1 by f derivative of this g of x is basically 0. Now how do we find the derivative? Derivative is given by this, shift and dy by dx, right? So given function derivative is x power 3 plus 4x minus 1, sorry, it's minus 1, and what x value is 0. So the answer is 4, but remember this answer is 4. The derivative of g of x is 1 by 4. That is the final answer. You can see in the solution set, it must be 1 by 4. Whatever method you use, answer will be 1 by 4. That's it. So I'll just do this shortcut method and then I'll explain you the detailed method. So let me do this. X to the power 5. See, we don't have mod phi 3. Why? Because there is no power phi and all to be solved directly. So we use this direct substitution. Write the given question and make it equal to what? Minus 2. Shift and solve and then press equal to. The answer is again 0 here. The answer will be generally 0, 1, 2 or minus 1, minus 2 within that range. Now, whatever the answer you get, just derive this. Shift dy by dx, x power 5 plus 4x minus 2 at, what was the answer we got? We got 0. So the answer is again 4. It's 1 by 4, the final answer. Let me just do one more because I want some other answer. So this is the first, and 17 and 18 are the same answers, 1 by 4, 1 by 4. Let me just quickly do this in calculator. Again, type it out. X to the power 5 plus 3x cubed plus x over here equals how much? It's 5. Shift and solve and then press equal to. The answer over here is 1. So now we derive this particular function at 1. X to the power 5 plus 3x cubed, and we have plus x. The x value should be given as 1. Okay, 15. So the final answer will be 1 divided by 15. You can see here. This is it. So that is the shortcut method. Since it's the electronic part, the shortcut method is more than enough. You can do all the other problems like that. But now, if you're really interested on what's exactly happening, why are we doing this, let me tell you. First of all, you need to understand we have been told f of x inverse is g of x. Okay? And then we have been not told to find inverse function, we have been told to find the derivative of that at some particular value x. Okay, so that's the thing. Now then, let us try to make sense of few things. Imagine I have f inverse of x. Now this is given as a, that's fine, I'll take it as x because already the function is in x, so they have given a. Let's consider that to be x itself. Let me write the formula first. It is not f. Derivative of g of x is given as 1 by f derivative of g of x. Okay. So here, for each function, you have x and y values, right? Now imagine x, y here. What about the inverse function? Inverse will be y and x, isn't it? So now the same thing here. What is the input? X is the input, y is the final answer. That will be swapped over here for this given function. Here we have y and x. That's the reality of the inverse. You can ignore these derivatives because we're using the formula, right? So instead of this, let me write it as x input value of the function f. And when we put it, whatever over here, say imagine I put 0. It'll be 0, 0 and then 1. The output will be 1. That will be the answer. But for the function g of x, because it's inverse, whatever you give y of f will be here. So let me just consider this to be x of the g function and y of g function. Now you can see here these both values are equal, right? Because y becomes input. The output of f of x becomes the input for the inverse function. That is the inverse, basically. That's the rule of the inverse. So these both are equal and these both are equal. Now here we have been given a value. A means the x value. See, now if I had written this as a, that's the input value, isn't it? So for a second, let me consider that to be x itself, because over here I've written an x. I shouldn't have written it, but anyways, the given function, imagine, is something else. Now here, what I know is the input of the g, this part. So input over here is minus 2. So what is minus 2 then? The output of the given function is also minus 2. Y of f is minus 2. So this entire thing is equal to minus 2. Doesn't matter what, because we know, because this input value is told, we have to find at that value, so the output becomes equals to minus 2. So that is the reason in the step 1 I tell you, just in the calculator put all this equals to the given function, because that is the output. Now whatever you solve, you'll get what? X value. X value was equal to something. We can just do it in the calculator. We'll get one x value. That x value, now just for, let me just look into the answer and let me see. Here, what is the x value? We get minus 2. No, not that. Minus 1, okay? So when we put in the calculator, we get x of minus 1. This is the input of the given function, which becomes the output of this one, right? So that is the thing. Now, what is the output basically? G of x means its y value. So this entire thing, y is basically this entire this given function, right? So that is the minus 1, whatever we find. See, look here, the input of the function f of x is basically the output of the inverse function. So the inverse function is basically equals minus 1. So that's why we change this to minus 1, and then we just have to derive it at minus 1 and 1 divided by that. So that is the understanding behind it. But for example, when I was doing my first year engineering, I used to always be so much confused with this concept. I don't know exactly which year, but I still remember when I studied, I used to hate this because I never could wrap around that thing. And it's fine because it's an electronic part. You can use your calculators directly and solve it. So you guys are lucky in that part. So here we will again use our calculators and solve this. All you need to do is write the given function x to the power 3 plus 2x plus 1, and you just have to press make it equal to what is the given value. A value is minus 2. Shift and solve. The answer is minus 1. So now you need to derive this given function x power 3 plus 2x plus 1 at minus 1 because we got the x value. So the answer is 5. The final answer must be 1 by 5. Similarly, you can, okay, this is now square root. I will solve this one as well. Let me just go to the last problem once. Let me see. Yeah, these both. I'll do this one. It looks more complicated. This is very straightforward. You can do it. Same method like what I'm doing now. So let's write square root x to the power 5. Then we have plus 4x cubed plus 3x plus 1. This all will be equal to whatever given value is 3. Shift and solve and then press equal to. The answer is 1. So now I need to derive this given function square root x power 5 plus 4x cubed plus 3x plus 1. You need to the x value was 1, I guess. I just forgot, we got a while ago. I think so it was 1. Let me just quickly check the x value first. Yeah, it is 1 itself. Yeah, so whatever answer we got is correct. Now here, whatever this answer, we have to take 1 divided by, right? So this inverse we need to find. It's basically 1 divided by 10 by 3. That means it'll flip. It'll be 3 by 10. That'll be the final answer. Or you can just, whatever the answer you get, you can put it as inverse. That is the final answer. Because remember, we are finding the derivative, f derivative of 1. We found in the calculator that was 10 by 3. But that is 1 divided by. So when it goes up, it'll be 3 divided by 10. So that's how we could solve these easily in the calculator. If you have any doubts, please post them in the comments. And remember, this is in the electronic part. So you will be given 4 options and there is no need of any writing method. So you can just do the calculator method, which I just taught you. Moving to the question 11, it is to find derivatives of trigonometric functions. Here we have to know few rules of trig functions. And they have just asked derivative, it's single derivative basically. So we can check answers using calculators as well. But it's very important to know the difference of what's happening here. Because if you don't understand this difference, there's no way you can use a calculator to solve this as well. Let's look. Sine x squared. This means it's basically sine x squared. Okay, sine is outside, the square is only for x. The sine square x means sine x, the whole thing is squared, because when sine function is squared, the entire sine x becomes power 2. Whereas if it's only squared to the x, it's only to the x. So here, when you see the outer function, because chain rule over here we are used, right? What happens? This one, it's like the outer function will be sine. Here the outer function is 2. If you look from outside, which is the outer function? Brackets is inside. This is inner, this is outer. Whereas over here, if you're peeling it up, which will be the first thing to go? This 2, whereas over here will be the sine. And what about this one? This is just sine 2x altogether. So outer function is sine itself. Now then, if you derive it, derivation would be f prime of x. Derive sine, it'll be cosine x squared. And then what is the derivation of inside term? X squared derivation is 2x. This is it, this is the answer. Now over here it'll be 2 times sine x, because we have to derive the power first. 2 comes down, and then what happens to the derivative of sine x? It'll be cosine x. That's it. So derivative of this 2 comes down, sine x, derivative of sine x is cosine x. It's positive. And then over here as well, we first derive the outer function cosine. It's not x now, it's 2x here. It's 2x, and then derive it as 2x derivative is just 2. That's the answer. Now over here, what happens? Same thing. This one is just like this. Derivation of cosine is minus sine, but we have square root x. Then we need to derive square root x. I'm going to use the rule directly 1 by 2 root x. That's the answer. Now here the square root is for the entire function, so we need to write 1 by 2 square root cosine x multiplied by derivative of cosine is minus sine x. And lastly here we have derivative of cosine is minus sine half of x, then multiply by half, because derivation of half x is only half, whatever the number that's remaining. So this is how we would solve these problems. You can see here, that's the answers. Now here they have not rearranged and written, I believe. Let me just see here. This one here, okay, they have just brought it up. Absolutely fine. They have written it as it is, but generally when we use the rule, it's going to be, sorry, let me show you. It's going to be written as 1 by 2 root x. Now, what is square root x formula? It is 1 by 2x to the power minus, sorry, positive half this is. And when you take it up, it becomes 1 by 2x power negative half. That's it. That's what's written in the solutions. But you can follow this as well. Generally, in the options, this form will be written. Now, I'll show you how you can check in your calculators as well. But you need to have your options. Since it's question number 11 in part 1, you have the 4 options. And we need a calculator for this. So what you do is use shift and dy by dx. Put in the question. Let me choose the first problem. Sine. Now you need to know it's x and square the x and then close the bracket. Because this is sine x squared, not the entire thing. And what is the x value? Just choose something more than 1. I just choose 1.5, because if it's 1.5, whatever the answer you get will be unique. It can't be from any other solution. So over here. But there is one very important thing before you press equal to. Now this is wrong. Why? Because it's a trigonometric function and we have in degrees. So press shift, mode and 4. Now it's in radian mode. Now whatever the answer you get, write it down. So here at x is 1.5, I'm going to get minus 1.8845, right to the nearest 10,000, like 4 decimals after 4 digits after the decimal point. And now what do you do is look into the 4 options. So this is your option, right? You might have different options as well. Now what you need to do is type this. Don't press shift and divide. Done. Only the given question you're deriving, not the answers. The answers are already derived. So you type them as it is. 2x cosine x squared, close the bracket. And calculate this at 1.5, whatever you consider the same value you must use. And look at this, it matches. Now let me change a single value here and calculate it at 1.5. It's not going to be the same. No other answer will match. Only one correct unique solution will be there. So now if I just put this over here, 2 over here, cosine x and multiplied with the cosine x. You might be thinking, why I've not multiplied here? It's fine. They will consider that as multiplication itself. 2 times, it'll automatically be taken. Even if I put a multiplication sign, it's no problem. At 1.5, the answer is 0.1411. Now then, if I derive the given function, that is shift dy by dx, sine square x, so I need to put sine x, close the bracket and square it up. But here, another thing, please try to put another bracket here properly, because now this clearly means that you're squaring sine, not only the x. And then x value was 1.5. And can you see it matches? Only one correct answer will match. This is how we can check any question over here. Let me go to the next page and try some. Over here it's tan functions. Now let me do the last one over here, which is a bit lengthy, but it'll just take time. All you need to do is shift dy by dx, sine, open the bracket. Oh, it's already, whenever you press sine and cosine, it already opens the bracket. That's fine. Now, where is tan? It's tan over here. And since it's tan squared, that means right x, close the bracket. And here, after closing this x bracket, I need to square it up. Is that okay? Or you can put one more bracket just to be, not to get confused. This over here squared. See what's happening here? Let me just show you. One of this bracket, the first bracket is for dy by dx. It automatically comes up. See, I'll show you over here. Shift dy by dx. It automatically comes up. It opens and closes by itself. Now what you have is sine. When you press sine, there's another bracket coming up. That is for the sine function. Here. And then we have tan. So, but I need to square the tan. So I'll open one more bracket, put tan over here, x, close the bracket for x. I'll close one more tan bracket, and then I'm going to square it up. And then here, it's not done because there's sine one more bracket. So now it's all the brackets closed and 1.5. Now I'll show you, if at all you have not closed a single bracket. Imagine this one bracket is not closed. You will get a syntax error. So that means somewhere a bracket is missing. Okay. So I know I've opened so many and I've not closed them all. So I'll just close it. And here we go. It's negative 3,370. We can remember that. Now here then, let us put the answer. 2 multiplied with tan x, close the bracket, multiplied. What is secant exactly? Secant x is equal to 1 by cos x. Whereas cosecant, CSC x, would be equal to 1 by sine x. And lastly, cotangent x would be equal to 1 by tan x. These are few things. Because in your calculators, you do not have secant, cosecant, and cotangent. You use these reciprocal identities. So instead of secant, I'm going to put 1 by cosine. And since it's squared, secant is squared, I'm going to put 1 by cosine x. I'll close the bracket again, and square it up. This is done, second term. And then what do you have? Multiply everything with, open the bracket because the brackets are there. Just all the 4 options, you need to just input it. Cosine, bracket is already open, but I need to square tan, so I'll open another bracket. Tan x, close the bracket, another bracket for the tan, square it up, and now close the cosine bracket. Now it's not yet over. I've done cosine bracket close, but there's one more bracket which I'd open. So that's the thing. Anyways, if you get a syntax error, just understand the brackets are not closed. So calculate this at 1.5. What's the answer? It's absolutely the same answer, right? Minus 3370.91. If you're still not sure, just go back in the video for few seconds, maybe a minute. You can see this was the answer we got when we derived this. So this is how we can do it. But if you're getting too much confused over here, absolutely you can use the identities and solve it up. Over here, it's just that you have to use secant identity and then tan identity. And here, product rule is used. Product or quotient rules. Over here, just product rule is used. And chain rule. So remember and solve it up carefully. So this is also all the same thing. Secant is 1 by cosine. Tan is as it is. So try them all by yourselves. That's the end of question 11, which is very simple, as you can solve all the problems of derivatives using calculator. It definitely saves time because, in the long run, when you're practiced using it, it will be quick. So every problem can be double checked using calculator, or you can directly use calculator as well when the options are given to you. Moving to the question 12, it is deriving natural logarithmic functions. It is similar to the previous question where we can use the calculator and solve it up. Let's look into the problems. Let me solve one of it properly. Here you can see there are 2 functions where you use the product rule. And the product rule is given by a, b. Imagine these are 2 variable functions. And we have a prime b plus a b prime. So now the same thing. X power 3 will be derived initially. X3x squared multiplied by b is e to the power x. Plus x power 3 remains as it is. What is the derivative of e to the power x? Derivative is the same thing, so we just write it as it is. And then we can, that's the answer. We can rearrange and write, or you can just look into the options and choose the correct one. Even over here, when you're deriving this, e to the power 2x derivative is the same thing, but chain rule multiplied by 2, because then we have to derive 2x. And cos 4x plus, now here e to the power 2x remains as it is. Derivation of cosine is minus sine 4x multiplied by 4. Why? Because derivation of 4x is 4. And then what we do is we look into the correct answer, which is the correct answer here. See here, what they have done is they have removed out some common terms. See, x squared and e to the power x is removed. I'll show you what they have done. E to the power x, e to the power x is common. Here x squared and here also power 2 can be removed out, okay, till power 2. So now we will have x power 2, e to the power x removed outside. So what's remaining here? Only 3, because this is gone. Plus, here 2 is gone, but there's still 1x remaining, and e to the power x is gone. So it is 3 plus x or x plus 3. That's the answer. Here as well, can you remove anything? Yes, e to the power 2x can be removed, and then and 2 can be removed. So 2 e to the power 2x removed outside. So this is gone. You have cos 4x plus gone. Over here 2 is gone. This is not plus, it's minus now. Why? Because sine is, derivative of cosine is minus sine, right? So minus remains. And 2 remains here, sine 4x. So that's the answer. Now you can see the options. These are the answers. Over here now, they did not take, yeah, they have taken, yeah. No, they did not take anything common out. So I'll just see, they have left it as it is. That's fine. That's the first step what we got. Now I will show you the calculator method. All we do is shift dy by dx and type in the question. Let me do the second one. It is e, that is shift and ln, that's e to the power 2x, and then multiplied it with cosine 4x. Now, another, again, remember, do not go ahead with the degree. You have to change it to radian, shift more than 4. Now it is in radian when there's r showing up in your calculator. And what is the x value? You can assume any x value, but take 1.5 or more than that, like 2 or something. Let me just take 2 for now, because I've been taking 1.5 for a long time. You can change this to 2. What is the answer? So derivative, this question, when you derive at x equals 2, what do we get? Minus 231.956. That's enough. And then no need of rounding off and anything, because this is not accurate. We're just start to select the correct answer. Now you have to put all the options in. This one over here, 2e to the power 2x multiplied by cosine 4x, close the bracket, plus e to the power, again 2x multiplied by minus sine 4x multiplied by 4. Let me close it. Okay, now did I close this? See, I've not closed the bracket here. Now there's no other bracket to close. That's it. Now we calculate it at 2, because we considered x to be 2 here, and see the value matches. Now please be careful. Many times what happens is students will put x value a different value and calculating value a different value. Then you're not going to get the answer. So stick to a single value. Now I just showed over there 1.5 and 2. You can just always assume to be 2. That's fine. What you just do is always take x values to be 2 here also. Always. Just don't change it. Then that's fine. I hope that is clear. Let me do some other values as well. Let me see this one over here. This one looks, I mean, they're all simple. But anyways, let me do the fourth one here. So first we derive the given function, shift dy by dx, x times 4 to the power 3x. And then what is the x value to be considered? I'll just take 2. Let me write it out. It's 38165.57 and it goes on. Now you need to make sure to put all the 4 options. Let me just show you. What I mean is, this will be the first option. Imagine 2 to the power x, and we have log is over here 2. Close the bracket. Calculated at what? 2. Is it matching with the answer we got for the given question. When we derive the given question at 2, we got something else. It's not the correct answer. You can eliminate it. That's wrong. Let's try the next option now. It is 4 to the power 3x. Open the bracket up. 1 plus 3x. T is taken as x variable. Multiplied with not log, it's ln 4. Close the bracket. Now calculate it at, you should calculate it at 2. I mean, I already had put 2, so it's already saved, you know. When I press equal to, it'll automatically calculate at 2. And look at the answer. Yes, absolutely, that's the correct answer. Whereas all the others will be wrong. I hope this is clear. Now, when I saw this question, when it's log, I remembered one very important thing. Last year, a similar problem was there for the exam, and my students last year had told me that they were not getting the correct answer by calculator for this log function. Very important thing to remember. Log is considered as natural logarithm. Whichever input values over here will just be considered as natural logarithm. So now let's just solve this up. Let's derive this t, that is x plus 2 to the power t. Okay, and what is the answer? At 2, this is the answer. Why? Because what do we use to solve this? We generally don't take log, we take ln. Okay, now here this is the answer, right? Make sure when you're putting all the 4 options, 1 plus 2 to the power x, don't type log, press ln. That's it. Now the answer is same, 3.77. Okay, now there's no other cases like that. Let's just look into the other options. There's no log, but anyways, I'll just do the 7th one and the last one as well. Here again it's the same thing. Derivative is shift dy by dx 1 by 3 to the power x squared. So x squared. Now take a x value of 2. The answer is negative 0.054. Let's just keep it in, I'll just gonna keep it in the mind, but if the exams don't do that, write it down. And then over here minus 2x ln, that's natural logarithm of 3 multiplied with 1/3 x squared. And here now calculated at 2 is the same thing. But if I put over your log, it's going to be different. So always take ln. If it's ln, it's fine. Generally, it's going to be natural logarithm itself, but sometimes you might see in the textbook there are some problems where the solution is given as log, but in your calculator you cannot take natural log. You have to take natural logarithm. Let us do this one over here. It looks okay. There is u and all, but just take it as x. That's it. Now here, what you do is shift dy by dx. Now actually they have written as f of u. Your answer will be in terms of u, okay, but here the answer is written as x, but that's an error. If they are mentioned in u instead of x, they have just written u. That's the only thing. 3 e is over here to the power tan u, that is x. Close the bracket, and now take x value of 2 and 1.948. Now let's look into all the options. Only one correct answer will be giving you the same value. Okay, it's shift E, this one. Now tan x multiplied, close the bracket, multiplied with secant, that is, open the bracket and split it out, 1 by cosine x. And then I'm going to square it up entirely because this is for the secant square. So that's the thing. Calculated at 2, it's 1.948. Now there, usually I know this was the answer 1.9 something, but I might forget it, so it's better to write it down, which I've not done. But you guys in your exam, please write the answers down and then solve it up. And similarly, you can try the other problems by yourselves. These are all again simple problems. Here as well, just put this over here, check it at 2, and this one derive it at 2. And all these as well. Here, these are all simple problems. Now let me just do the last one as well. Deriving, the question must be derived, shift dy by dx, and then natural logarithm square root 8x, and now close the bracket. Now when you're closing the bracket, if you close it up over here, this is wrong. You need to close it up just after the square root. This is a proper closing of brackets, and then x value we take it as 2, the answer is 0.25. But what about the answer? Now just put this up, 1 by 2x, and x value was 2, yes, it'll be 1/4, and that is 0.25. Sorry, it's 0.25 or 1/4. That's how we can check any problem. So all derivative problems can be easily solved using calculator, may it be trigonometry, logarithm, anything. But for trigonometric function, make sure you keep it in radians mode and then solve the problems. Question 13 is similar to the previous questions as well. It's about derivatives of inverse trig functions. Here also we can use the calculator to directly find the answers, or you can use the rules of trigonometric functions, the inverse trigonometric rules and the chain rules, and then we can solve it up. Here to solve using calculator method, you need to know the options. You have to have the options, otherwise it's not possible. And there's one important thing here. Now we are dealing with what? Sine inverse, cos inverse, tan inverse. Whenever it's sine inverse or cosine inverse, remember the domain is within, for differentiability, it's within -1 or 1. It should be like this. Even the same thing for cosine. Whereas for secant x and cosecant x, you need to make sure it is other than these. It can be anywhere from -infinity to -1 and 1 to infinity. And for tan and cotangent, you don't have to worry, any number works. But if there is any undefined values, then it doesn't. So now let's try these. Here, let me type shift dy by dx, sine inverse shift and sine x cubed plus 1. Now you need to close the bracket carefully because this is sine bracket and then this is dy by dx bracket. And what is the value? Let me show you for phi. Will it work? No, it's a math error. Why? Because the domain is beyond this. Now here, what happens if I put, say, 1? Again, it's beyond this. Now let me put anything like 0.5. That's half. Why is this? Because over here we have power 3, right? Plus 1. So you need to take this into consideration. If I put any positive values, no matter what, it's going to go beyond this x value. So when it is not working, it's fine. Just put negative over here. Say you put minus 0.5, you will get an answer. That's it. Why? Because over here, whatever the answer is, must be less than 1, isn't it? How can it be less than 1? If you put 0.5, it's going to be, when you cube it up, it's going to be 0.6 something, 0.6 or something, but it will be minus. So the final answer will be less than 1. That's the concept. Or you can try something like other 0 point, but negative values. It's not going to work with positive because we have cube, and plus 1, it should be less than 1. So try something like this, or you can put it as 0.25. You will get the answer here as well. Okay, choose one answer. I'm just going to choose negative 0.5 here. And it's 1.5549. I'll just write it out because you need to make a habit to write this out. At x is equal to minus 0.5, the value is 1.5491, and it goes on. Now then, you will have 4 options. Imagine these are your 2 options. You need to type them out. I'll type the right side first. 1 divided by 2 times square root, 2 times square root of x multiplied by 1 minus x, close the bracket. What is it? Calculate not at 2, at negative 0.5. And here you're getting a math error. So that can't be the answer. Let's put the correct answer now in over here. It'll be 3x squared divided by square root 1 minus here then x cubed plus 1, close the bracket and square it up. Just typing it out, make sure it's typed properly. And now calculate at minus 0.5, which is already typed. The answer is how much? 1.5491. Yes, that's absolutely the correct answer. No other option can give you the same value. So this is a very easy trick to solve any trigonometric, any derivative, sorry. And over here as well, let's do this one. You need to press shift dy by dx, sine inverse, that is shift and sine, and square root x. Now don't close the bracket inside the square root, go out and close the bracket. Now it's done. What is the x value? Here, remember, it should be less than 1. So what I'll do is I'll take positive 0.5 because I can't take negative 0.5. We got an error, right? Why is that? Because can you have any negative number inside a square root? No. If it's cube, odd numbers, it's fine. But this is root 2. It's even. It's not possible. But this will give me the answer. Positive 0.5, yes. Then we take even, like say, 2.5. Yes, you will get the answer. Okay. But now I'll consider zero point 0.5. It's an easy number to remember. Let's just put it over here. 1 divided by 2 square root x times 1 minus x. Close the bracket. Now calculate this at 0.5. You must get 1 and you will get 1. And if you calculate at 0.25, it was 1.15 or something. You can see that was the answer. So any unique value of x, you will have one option which matches, and that's your correct answer. Even over here, it's the same thing. Let me do the second one. First, shift dy by dx, shift and cos inverse. 2 divided by x. Sorry, it's x. Alpha and this symbol. Now go out over there, press next and now close the bracket. Now here, what can I type? Can I type 1? Then cos inverse of 2, x is beyond the limit. I even can't type 2 because it'll be just 1. It should be less than 1. So see over here, if I press 1, it's math error. Absolutely. For differentiability, even it should be less than that. So no, it doesn't work. So what happens? I can take anything more than 2 here. If x is more than 2, if I take, say, for example, 2.5, it'll be less than 1, right? This number will be less than 1. So I'll take 2.5 here. Say I'm getting 0.5333. So let's look into the answers. And now if I solve this at 2.5, 2 divided by x square root of x squared minus 4. Calculate this at what? I think so. I took 2.5, yes. And it was 0.5333. Yes, that's it. So this is how you can easily solve it up. And now if it's tan inverse, it's very easy. Let me do this, shift and dy by dx, tan inverse, again shift and tan of square root x. Now here, close the bracket. If you don't close it, you will have an error. Now I'll just take any value. I'm just going to take 2. Okay, it's more than 1, but still you will have an answer. Now just put all the options in the calculator and check. It is over here 1 divided by 2 square root x, and open the bracket here. See, it's only square root x. Now it's separate 1 plus x. Now close the bracket. Calculate it at 2, I believe. So that's the answer. I can't remember which values I input, so it's very important to type it out. Okay, you have to type it out. That's important thing. Now let's do this anyways. I think so this is correct. I mean, I don't know which x value I forgot because I just blanked out for somehow. Now then, I'll keep this up over here because I need this. Shift tan inverse 1 by x. So I'm just going to take, now this is not going to help. It's dy by dx. Shift dy by dx. That's over here. Now tan inverse of 1 by x. Close the bracket. Now if you're thinking, can I directly substitute over here instead of x? No, you can't. You have to type x as the variable for d by dx. Otherwise you won't get the answer. Now here I'm just going to take, let's say 1. So you will get some answer. Now if you put over here 1, it's directly negative 1 by 2. Why? 1 plus 1 is 2. So you can prove it. Yes, this is the correct answer. All the others will be wrong. So that's how you can check them. Now I'll do this one over here. Shift ln gives you e, but look here, I need to derive this. So shift dy by dx. Now I need to press e to the power tan inverse of 1, of x. And I'll close the bracket over there, then done. Now since it's tan inverse, I can take any value. I'll take 0.605. I'm going to remember this, or you can write it down. Now I'll look into the options. It's 605. So now here it is shift E, tan inverse of x, close the bracket, down we go, 1 plus x squared. Calculate it at, okay, 2. That's, yes, it's 0.605. Here we have secant inverse functions. How would you do this? And you might be thinking, okay, we know that secant x is equal to 1 by cosine x, right? Because this we know from reciprocal identity from long back. But do you think for inverse, secant inverse x, is it just 1 by cosine x to the power minus 1? Or do you think it's 1 by cos inverse x? If you're thinking any one of this, both are wrong. The actual thing is secant inverse x is equal to cosine inverse x. Not x, it's 1 by x. That's the only thing. Because there's a relationship of this. You do not need to know the entire relationship, but just remember so much 1 by x. This is all that matters. Okay? And you know the range for secant over here. It's any values. Even if you do not need to remember this. If you don't get the answers, just do some trial and error, and then you will directly get it. So that's one thing. So now we will solve over here. This one, remember, you need to write cosine inverse of 1 by x to the power 4. This is it. Let's use our calculators and solve them now. I'll do both these problems. The first one is very simple because it's just secant, right? It's shift dy by dx, 4 multiplied by, what is it? 1 by cosine, in this case, x to the power 4, and then you just close the bracket, and then you take any x value here. That should be anything more than 1. So I'll just take x as 2, but I'm getting a syntax error. That means I have not closed the bracket. See, this is the thing. I've not closed this bracket. Now it's all right because this bracket is already opened by d by dx. Now you can see it's negative 40.18 and it's in radian mode. This is very important to be in radian mode at x is equal to, I forgot what x I took, 1.822. So let us just look back to the x. I'm having goldfish memory for somehow now. X is 2. Now then, I need to look into the answers. I need to have the options available. Otherwise, you cannot solve this. So what I'll be doing over here is clearing that off. Type this 16. Now it's all in the numerator. So I'll just write 16 x cubed. Then what do we have? Secant. That is multiplied with 1 by cosine x to the power 4. Close the bracket. Even close the bracket here. Multiplied with tan x power 4. Sorry, it's power 4, and you just close the bracket properly here, and that's it. And calculate it at 2, it must be 40.1822, and that's the answer. Yes, absolutely, only one will be the correct answer. But we have done secant before, but now let's do the secant inverse, which is more interesting. So here I've written it's yeah, this is the form for secant inverse. For secant, it's just 1 by cosine. Now then, let us type this out. Shift dy by dx. It's 4 multiplied by secant. Now secant inverse is just cosine inverse. That's it. When you have secant inverse, write cosine inverse. But only here the x value, you write 1 divided by whatever the x value here. Now if you're thinking what happens if it's a cosecant inverse, then you have to just have sine inverse 1 by x. Now let's write it out. 1 divided by x to the power 4, and then you have to close this bracket. Only one bracket I have opened for cosine inverse, and that's closed. That's it. Let me take a value of 2. Why? Because it's in the domain 0.5000. Let's try this. I'll write it out over here, 0.5009, and it goes on. Let us try this now. It's 16 divided by x square root, not squaring it, square root x to the power 8 minus 1. Now calculate at what? At 2, because I've taken 2 itself, and it's matching. Only one correct option will match. So by this method, you can solve any problem, whether it's inverse, non-inverse, anything. Let me do this one here, because left side is pretty straightforward. What about this right side, cosecant? So it's just shift dy by dx. I have to write cosecant, that is shift and sine 1 divided. Okay, I've not pressed shift properly. It's shift and sine. Sine inverse must be there. 1 divided by x. Now close the bracket here. And x value will be equal to what? You can take any, I'll just take it as 2. I'm getting minus, let me write it over here. Let me clear all this, minus 0.2886. And then look at the answers. We have to write minus 1. I'm writing minus up, it's fine. Or you can write it outside, that's up to you. X square root x squared minus 1 calculated at 2. And the answer must be the same thing, minus 0.2886, and goes on. This is how we can easily solve all the inverse trigonometric functions. If you have any doubts, please post them in the comments. Just be careful with the radian mode, and when it's secant inverse, it's cosine inverse 1 by x, and when it is cosecant inverse, remember it is sine inverse 1 by x. Question 14 is about linear approximation. It would have been a very easy question if they had just asked you to find what is the estimate of this. But since this is the electronic part, we can use calculator, but there is two parts. I will just show you A and B. The first part would be applying the linear approximation formula and getting it into this equation. Whereas the second part would be using this estimate. You're finding this linear approximation and finding the estimate of that. So finding this estimate is very easy. Let me show you in calculator. All you do is put square root and whatever is the value, 1.2, and that's it. That will be the answer. It will be 1.1 is the approximated value. So you can easily find it in calculator. The reason for a linear approximation is to find this difficult problem without calculator. There is a chance instead of giving you these as the option 1.1 or so on, they might give you half plus half x. So anyways, let's use the formula and solve it. The problems are not that difficult, they are straightforward. You should just remember a formula. The linear approximation of x would be equal to f of x naught. So this is very simple. Whatever x naught is given, the same thing. You just apply the value and you get that. Plus derivative of x naught. Now this is another thing. You should derive this function and then multiply it with x minus x naught. So we will see this step by step. First, you need to know what is the x naught value. What is the x naught? Over here given as 1. So we need to find f of 1 because f of x naught is f of 1, right? What is f of 1? Square root 1. That is 1 itself. Now we need to find derivative. So what is the function derivative of x would be? Root x is there. What is the derivation? 1 by 2 root x. Now substitute the value of x naught. X naught is 1, isn't it? So it will be 1 by 2 square root 1. So it will be half. Why? Because 1 by 2 times square root 1 will be 2 itself. Or 1 by 2 remains. So first thing is x naught. X naught basically is given as 1. So we find f of 1. So over here, let me just substitute. It's 1, right? And then f prime or f dash or the derivative of x naught. Derivative of f of x is here. We substitute the x naught value and get half plus half. And then what next? Multiply it with what? X remains, but we have minus 1. So we will write this as well. It will be minus 1 here because x naught is 1. So now we will just multiply it 1 plus half x minus half. So 1 minus half will be basically half plus half x. So this is your answer. Now if you substitute this x value instead of 1.2 and then solve, you'll get the radical. See here, this is it. This is the answer, half plus half x. And if you substitute x as 1.2, you will get 1.1. That is basically the radical of 1.2. Let's do one more problem here. Again, it's the same thing. It's just that you need to remember derivation. You need to remember the formula. That's the first thing. Remember, linear approximation of x is first you need to derive it as it is with x naught, whatever given, plus derivative of x naught multiplied with x minus x naught. This is it. So now first let's solve. What is x naught? 0. So it'll be 0 plus 1 the whole power 1/3. 0 plus 1 is 1. 1 power 1 thirds is 1 itself. So then we will derive this given function. So here 1 by third comes down. It's the power rule. 1 by 3 comes down, multiplied by x plus 1. What is the 1 third minus 1 will be negative 2 thirds. It's all by power rule because we subtract this by 1, isn't it? So 1 thirds minus 1 will be minus 2 by 3. And now we will substitute 0 here. Instead of the x, we'll substitute 0 because x naught is 0. And we will have 1 thirds times x is 0, so it will be 1 to the power minus 2 by 3. Anything 1 raised to power anything is 1 itself, so here the answer will be just 1 thirds. And this is f derivative of 0. So let us substitute back over here. What do we have for x naught? F of 0 is 1 plus 1 thirds of x minus 0. So here the answer is very simple, 1 plus 1 thirds x, because you multiply here, 0 is gone. So it will be the answer. If you substitute 1.2 over here, then you will get the answer for in decimal as well. But you don't need to do that. So the final answer is 1 plus 1 by 3x. Similarly, do the other problems by yourselves. Here, see, we have chain rule. When we derive it, where is the derivation? 1, see, they have taken it as half to the power minus half multiplied by 2. Why? Because we have to derive whatever is inside as well, right? It will be 2x derivation 2. And then this and this cancels out. And we just substitute over here. See now, this is not done. We don't use this. We have to substitute what x value is 0. Then 9 to the power minus 3 is 1 by 3. So you can just use the calculator. 9 power half. It'll be 1 thirds. And then you substitute back. That's your answer. Similarly, guys, please do these. Just remember what to derive. You should know the derivation rule and substitute and solve it up. This one over here, you can just put in the calculator. Just put 2 divided by 0.99. You will get this answer in the calculator. Okay, let's do this one because it's trigonometric function. Now, formula doesn't change. It is approximation will be equal to f of x naught then plus f prime of x naught times x minus x naught. Now then, over here it will be f of x naught is I'll directly substitute as 0. So here we have sine 3 times 0. Sine 0 is 0 itself, so here the answer is done. Now what is f prime of x? First let's do. It'll be sine derivative is cosine 3x multiplied by 3. Why do we write this? Because it's the chain rule. So cosine 3x is done, multiplied with 3. And now then, let us substitute the f prime of 0 because x naught, right? We need to find for x naught. So it'll be 3. Let me write it first. Over here, 3 times 0, cosine 0 it'll become. What is cosine 0? It's 1. So the answer is 3 basically. Cosine 0 is 1. 1 multiplied by 3 is 3. You can put it in the calculator. And now then, let's just write it out over here. What is f of x naught? It's 0 plus derivative will be this one is 3 over here we found out. What is x value? X itself minus what is x naught? 0. So we have to multiply this 3 inside. It'll be, see, 0 is gone. 3 times x. Then 3 times 0, that's not required. So answer is 3x. Now you can directly check this value as well in the calculator. So let's type it out. Sine 0.3, but make sure you're changing the mode to radian. Shift mode 4. And the answer is supposed to be 0.29. So that will be 0.295, 0.3 approximately. So that's the thing. You can check this. The second part is very easy. You can try it in the calculator. But the first part is the one which you need to solve it by the formula. Same thing over here. Please try it by yourselves. You'll get it. Okay, let's just do this. It looks a little bit complicated because it's pi. Okay. So what would be the answer? Here, sine 3 is 0.14. You can see what is approximate. Okay, now here you don't have this option at all, right? 0.14 is not there. Let me just solve this up. Pi minus 3, you can see it's 0.14. The approximate value is equivalent to the answer. So you can just solve all the 4 options and get the correct answer. But what do you do for the first part? Now let's solve it using the formula. So your linear approximation is given as f of x naught plus f prime of x naught multiplied by x minus x naught. So we need to find what is, now x naught is basically pi. That is how many degrees. You can consider in degrees as well. It's 180 degrees. So let me just substitute over here. First of all, I'll write one in detail. X naught means the sine x becomes x naught, isn't it? So over here, x naught value is given as pi, so it will become sine pi. Now then, what about the sine pi is 0. So it starts with 0, 90 degree, 180 again 0, and it goes to 270 and 360 is 0, right? So we know this is 0. You can use your calculator, guys, but make sure you're putting in radian mode. Now then, what is derivative? We need to derive this f derivative of x naught. I can directly take it as, because I've written over here, is cosine x naught. Now, what is the value of x naught? It's pi, right? F derivative of pi would be equal to cosine pi. What is cosine pi equal to? So it starts, cosine function always starts up over here, isn't it? It just goes down, and then you can see it's minus 1. It's not 0, it's not 1, it's minus 1. You can just put in the calculator, you will get minus 1, so the answer is minus 1. Now you just substitute back over here. F of x naught, see basically this value, f of pi or x naught, it's the same thing, right? Is 0 plus, what is derivative? Over here we have minus 1. And then after that, multiply x minus pi. I hope this is clear. Now what happens is this minus 1 is multiplied inside. It becomes minus x and plus pi. So you can write it as pi minus x, or you can leave it as minus x plus pi. But since you're looking for options, your options will be written as pi minus x. The positive will be written first minus the x value. That's it. So you can follow this. This is more easier. You do not need to draw the graphs. Over here, you can just use the calculator to find the values. And that's how we get it. So that's the answers, guys. And that's another easy question. Just remember the formula. If it was part B, you can directly use the calculator. But for part A, you must use the formula and solve it up. The final question in the electronic part is using L'Hopital's rule. We have done the same topic in the writing part. That's question number 20. But since question 15 is an electronic part, I'm going to use the shortcut methods. We'll use our calculators for this. All you need to do is type this given equation as it is in the calculator, that is x squared, this is the limit that is given, so x plus 2 divided by x squared minus 4. Now when the limit is minus 2, let me write it out over here. You need to take two values which are very close to negative 2. It can be minus 1.999 and minus 2.0001. Now negative 2.001 is the lesser value. So I'd write before, and then greater value is minus 1.99. Whereas over here for 2 it is 1.999 and 2.0001. All you do here in the calculator is calc and then type the first value, whichever you can take, negative 1.999, and the answer is negative 2.25. It's negative 1/4. That's the quarter. And let me check at the right side as well. Minus 2.0001. Is it the same? Yes, it's negative 2.5. It's negative quarter. What about this one? Let's write it out. X squared minus 4 divided by x squared minus 3x plus 2. And all we do is calculate it at now positive 1.999. We're getting over here 4. See, it's almost 4. And then calculate it at 2.0001. And over here, we are just getting 4 because I put many zeros. But if you are just put, say, some zeros, you will get like this, 4.001 or 3.999, something like that. So that is the answer. Very easy problems. Please do these by yourselves. Now, let me do this one because it's infinity, isn't it? Same method, 3x squared plus 2 divided by x squared minus 4, and calculated at infinity means it's just a huge number. That's it. There is no minus infinity plus infinity. The answer is 3. Here, the same thing. We type the equation, whatever is given to us, x squared plus 4x plus 3. And now what do we do is we just calculate it at minus and a huge number for infinity. That is, see now this one over here, minus 8, 10 to the power minus 8. It means there are 8 zeros here before 1. So it's minus 0.000. It's practically 0. So the answer is 0 here. Why? Because it's almost 0. Now here as well. Now here, you can try this by yourself. It's by shift and E. Then you can get the exponential function and then you can solve it up. Is 0 means it's minus 0.001 and positive 0.001 in your calc values. But what about this right side? This sign instead of t we'll put as x, and then we have shift e to the power 3x minus 1. Press next and then come down and write minus 1. I know in my class when students were solving, they write minus 1 here and they try to do the shortcut method. It doesn't work. You need to press next minus 1. Now it would work. Now calculate it at negative 0.0001. I'm going to get wrong answer here. This is not the correct answer. Why? Because I have trigonometric function and it is in degrees. This is wrong. You need to press mode and there is, shift and mode. Shift, mode, and option number 4. Now it's in radian. Now I can calculate at minus 0.0001. And this is the correct answer. It's 0.333. That's 1/3. Let's try it at the positive 0.001. 0.0001. And what is it? Again, it's 0.33. So it's 1/3. Why? Because if you put 0. A lot of 3's in the calculator, automatically it gives you 1/3. Or you can do the easier way. You'll have 4 options. 1/3 is one of your options. Press equal to and then press SD. You'll get in decimal form. It's 0.33. So try these by yourselves, guys. Now over here, doesn't matter you have inverse function. Let me do that. It's sine. Sorry, it's not cosine. It's sine x, close, okay, x, and then close the bracket, divided by sine inverse is given by shift and sine, then x, close the bracket. Now calculate it at 0.0001. You get 1, and you can also calculate it minus 0.0001. You're getting the same one. If at all you get 2 different answers, that means it does not exist. These are the same thing over here. You write 2 before x and you can see the values. Now this is undefined. Let us just do this one. Why? Because cosine, it's shift and cosine, x, close the bracket. Over here it's x squared minus 1. Now calculate at what? Minus 0. Let me take minus 1.0001. It's an error. Well, okay, let me just take smaller values, minus 1.01. Now still an error. Why? Because it's undefined over there. Okay, now what if I take other value, calculate it at 0 minus 0.999. Over here I'm getting minus infinity, but one you're getting undefined value, and one more it becomes an error. So why? Because you're getting 2 different answers. We're not getting minus infinity in both the cases, right? So therefore we tell it's wrong. Okay, so that's the answer. So one, we are getting error, math error, which is undefined, and one more we are getting a big value. If you just keep on changing over here, minus it's 0.009. Sorry, it's 0.999. See, here you're getting minus infinity. It goes to be a big value, but over there was error, so it's 2 different values. We tell it's undefined. But over here, generally you are getting values. Most of the time, they will give you answers with values. You should just check and you'll get the answers. Tan, sine, everything can be easily put in the calculators. And that is the end of all the multiple choice questions. If you have found these videos helpful, please share it with your friends. Let them know about this channel, Best Math, where you can find all the end of term exam questions and exam lessons explanation for free. And I just want to thank all the students who like my videos, who share my videos, and all the gratitude comments. I really thank you so much. Your comments really make my day. A single thank you always puts a big smile on my face. Thank you very much. And I wish you all the best in your exams. I hope everyone does well. If you have any doubts, any clarifications, please do post them in the comments and I will get back to you.